Hello, this is part 2 for my Linux workstation and server PC build guide. This video is going to cover the part selection. Part 1 was the introduction. If you haven't watched that yet, please check the link in the description to give that a watch. And once you're done with this video, part 3 is also available. That is going to be the actual PC building part. As I said in the earlier part, I chose to split this up because it was getting really long. But if you prefer to watch the video in a continuous format, the full-length video is also available and linked in the description. And now, on to part 2. So, for me, I chose to go with two Intel Xeon E5 2650 V2s. Let's talk about why. In the CPU world, you've got a couple options. You can go with consumer-grade chips, so that would be your Intel Core series or your AMD Ryzen series. Or you can go with server chips. And I guess in the middle, Intel used to have their Extreme Edition processors, and AMD has like their R9 5950X, which would be past a regular consumer chip. And I guess let's briefly talk about the advantages versus disadvantages of each. Let's talk about some differences. These chips, for example, do not have built-in GPUs. Just like how I guess most people that use Ryzen would be familiar with this fact, but anyone coming from like an Intel Core series, all of Intel's Core series processors essentially have built-in integrated graphics, whereas something like Xeons or Intel Extreme Editions won't, and neither would Threadrippers or Epics for that matter. So that's one difference. The other difference is if I just turn these around, you'll notice that the sockets are very different. Intel's consumer chips used to follow the LGA, well, first it was 776 for, I believe, the early chips, especially the Core 2 era, and then they moved to LG 1155 for Sandy Bridge, Ivy Bridge. Haswell was a LG 1150, and then that's about when I stopped caring because they kept changing the sockets every other years. These aren't LGA 1150, these are LGA 2011. So Intel Xeons have also had a couple of different sockets over the years. So these are from the Ivy Bridge era, and I'll talk a bit about what that is. And they use the Intel LGA 2011 socket. There's also the LGA 2011-3 socket that was then used for Haswell and so on and so forth. So one thing you might be surprised by is how much cheaper these server chips tend to be compared to their consumer counterparts. After all, each of these chips has 8 cores in them. And mind you, this is from a couple of years ago, so before 8 cores was commonplace or common in people's desktop computers. So you have to remember that for the longest time, Intel had essentially capped out the maximum number of cores in consumer CPUs to 4 cores. So ever since Core 2 Quad, all the way up to, I suppose, like the latest couple generations, Intel CPUs have always been, the top ends have been quad-core, and you would have had to buy an Extreme Edition if you wanted more than that. So if you go on eBay and you search for something like an Intel i7 4770, up until 2 years ago, that chip was still going for $200–300, even though it was almost a 10-year old CPU. These things, on the other hand, the pricing for these is the, as I said, E5 2650 V2. These can be had for about $100 a pair, and the lowest ends are even cheaper. Now, back to the consumer versus server CPU debate. Generally, a big part about choosing CPUs tends to be motherboard support, because CPUs will be available on the used market for quite some time, but it's usually the motherboards that tend to get you when you need to actually find them. And you're going to spend more on the motherboard than you will on a CPU, in most cases if you're going for older hardware. So, another part of server chips is that they're not overclockable, because for a server, your number one concern is stability and usually efficiency. Because if you're in a data center, you're going to have hundreds of these devices, and even a couple of watts worth of extra power envelope could mean thousands of dollars in power bills over the span of a year. So these are always built to be power efficient first. Now, that should come, when I get to the coolers, I'll talk about why then that's a bad choice. But let's go back to the CPUs for a minute. These can be used in essentially 2 types of motherboards. There are your workstation motherboards and your server motherboards. And I'm using a server motherboard, and I'll talk about the differences in the motherboard section. But it's something to keep in mind that if you're using a server board, it's going to be harder to use as a workstation, and if you're using a workstation board, well, then you have an expensive server. And you're going to be lacking some server-based features such as IPMI, for example. Of course, another thing to consider is if you want to go single socket or dual socket. Single socket would be having one CPU. That would be something like an Intel Xeon E5 1650. And if you want to go dual socket, then you need to keep that in mind when you're choosing your motherboard, because now this means that you're going to need to find a board that supports 2 of these CPUs. It also means you're going to have to... That also comes with several side effects. For example, CPUs provide the PCI Express Gen, so these support up to PCI Express Gen 3. And CPUs are responsible for providing those PCI Express Gen 3 lanes. So this means that in some cases, your PCIe sockets might go to one CPU or the other, and between the CPUs, they're going to have to use a bus. And of course, the bus speed might be a limiting factor if you're using processes that might require more than the total amount of cores in one of these chips. Another factor to consider is then going to be your chassis size, because if you pick a motherboard that's a lot of dual socket motherboards, and particularly server boards, are going to be a large form factor. So in those cases, you'll have to keep that in mind, because if you end up with a board that's SSI, CEB, or EEB or something, that's not going to fit in your normal case. And even in my case, with just an EATX motherboard, I've had to make a couple modifications to the case. So we'll talk about that as well. Now, I guess before I get too deep into this, let's talk a bit about the alternatives. So compared to having a single consumer grade chip, those would have had the advantage that, you'll have built-in graphics. But besides that, these are probably the better way to go. And I mean, compared to Team Red versus Team Blue, you need to remember that AMD really didn't have a competitive offering in the server space until a couple of years ago, which is when their EPYC CPUs launched. Before that, the AMD server CPUs were AMD Opterons. And while Opteron is great, Opteron also isn't really the best architecture in terms of IPC or in terms of single-threaded performance. It's, I guess, a slightly older architecture, and you'd be looking more from the FX era at that point. Now, I said that these are Xeon E5. You might have noticed that Xeons come in E3, E5, and E7 varieties, just like Intel Core i3, i5, and i7. What is this, and what does it mean? So, Xeon E3s use the LGA 1150 socket. For at least for this generation, they will use LGA 1150 or 1155. Essentially, they will use the same socket as the consumer end CPUs, not these workstation grade CPUs. And that means that you're really, once again, going to be capped at 4 cores. Because LGA 1150, the highest end CPU that Intel had, would have only been a quad core. So that's something to keep in mind. Now, then we have the Xeon E5s. E5s were meant for workstations and small business or medium business servers. So this wouldn't be your big offerings from like your Dell or your HP with the massive rack mount units. Those will be your E7s. Your E5s will be what you find in, for example, content creation machines, where you might want high performance CPUs, or for scientific workloads, right? Where for engineering, for CAD, for SolidWorks, so on and so forth, where you want a lot more grunt and a lot more horsepower compared to a typical consumer platform. But you still want to follow standards, right? You still want a standard motherboard in a standard case so that you can plug in any accessories you need, so on and so forth. Your E7s are where you get hyper specialized. In fact, E7s can be had for even cheaper than these E5s. But once again, as I said, the cost is usually in the motherboard, not the CPU when you're going back a couple generations. So a problem that you are going to have if you are using E7 CPUs is going to be finding a system for them. And in many cases, those are the hyper-specialized ones by folks like HP or Dell or IBM, your big mainframes essentially. Whereas E5s are a lot easier to find. Now, these share a lot of similarities with the Intel Extreme Edition CPUs, right? Just like how the Xeon E3s are essentially the workstation or the server version of the LG 1150's chips of your regular core. So LG 1150, as I said, in the Haswell generation was your Core i3, i5, i7, Pentium, so on. Just as the E3s, or I guess the if we divide the socket and you have like your consumer versus enterprise, that's your enterprise version of the LG 1150 socket. In the same way, these use the same socket as the Intel Extreme Edition CPUs. So that would be something like your 5950X or 5960X, 4930K, so on and so forth. I forget the exact numbers that Intel used, but those would have been your 6-core or maybe your 8-core in the case of Haswell E for prosumer applications. Essentially, we're somewhere between about where like the Ryzen 9 5950X or something would fall today. Now, those used an X79 chipset on the motherboard, and these use a C601, and I'll talk about the similarities, at least for LG 2011. LG 2011-3, which something like the 5960X I mentioned would have used the X99 chipset, which comes with a couple improvements, but we'll get to that in the motherboard section. All right, so I guess that's the E3, E5, E7. So if you want high performance, and I would suggest looking for E5 chips, and you can go for either 1 or 2 depending on your use case. So these CPUs are from Ivy Bridge E in terms of the generation. So Ivy Bridge would have been your Intel 3rd Gen core series. So that is your 3770K, your 3670K, your 3570K, so on and so forth. So that would be your Intel 3000 series in terms of the core. Intel 2000 series was called Sandy Bridge on the core, and those are Intel, those would correspond to your 2650 without the V2. So Xeon naming schemes are a bit wonkier compared to consumer ones. And this is, remember, I'm not going to talk about the Xeon silver, gold, platinum stuff, which is what they're doing these days. I'm talking about the era that these come from. Now, you might wonder what era that is. That would be, I believe, around I would say 2014 is when these chips would have been out on the market. It's probably late 2013, because server and workstation chips are always one generation behind from the consumer chips. So that would be when Haswell launched in the consumer, which means that would be when Ivy Bridge E, one generation behind, launched in the prosumer and workstation space. So Xeon, the generation is noted by the last after the V, right? So if I have just a 2650, that's going to be a Sandy Bridge E part. If I have a 2650 V2, that makes it an Ivy Bridge E part. If I have a 2650 V3, that makes it a Haswell E component. And then there's a V4, and I forget when they switched to the gold Pentium naming scheme. Now you might then wonder what the heck the 4 digits actually mean. So in this case, I said 2650. Well, the 2 defines how many CPUs it can work with. So if I have a 1650, that can only work with a single CPU in the system. If I have a 2650, then that means that I can pair this with a matching CPU, and we can do dual socket systems. If I have a 4650, then that means I can do quad CPU systems. If you go up to the Xeon E7 series, which I said something like your Dell or your HP integrated servers have, then you'll see CPUs starting with 8. That's because those systems can have up to 8 CPUs in some applications. All right. So then what the heck does the 650 mean? Well, that's kind of just Intel's tiering scheme, right? So for example, in the 2600 series, you would have had your entry level would have been something like your 2620s. Then you have your 2650s. Your very high end for this generation would have been 2697s. And I believe those would have been 10 or 12 cores each. So the system starts with 2620s. Those are your 6 cores. They're slow. I don't think you should go for those if you're going to settle on this generation. At this point, I don't think you should necessarily go for Sandy Bridge either. Ivy Bridge is based on 22 nanometer lithography. Sandy Bridge is going to be 32. So something to keep in mind. Then you can step up to 2630, 2637, 2650. Then of course you'll end up with 2667, 2670, 2680, 2690, 2695, 97, all just in the one generation, right? So I said your 2697 would have been your top end. So that is a 12-core chip. The 2620 is your entry level. That is a 6-core chip. And I would say this is actually probably the perfect middle ground for a workstation or for a NAS build. These are 8 cores each, 8 cores, 16 threads. So that means that one of these will get you 8 cores. Now, as I said, once again, these days, oh, you can get 8 cores from a Ryzen 1700X, getting that on the used market. But I would argue these are a lot cheaper. And once again, I'm going for value, right? We're going for bang for the buck. We're going for performance per dollar. And in that sense, I think that you're going to get, yes, these are going to be lower performance, but they're also a lot cheaper. 2620s, really cheap. You can get them for less than 20 bucks. I would say that this is probably where you want to be. So these are, usually you'll be paying about $60 per CPU, or if you buy 2 of them, you can generally find it for about $100 to $120 Canadian for the pair. And that's about the price I paid for these. I think this would have been about well, I bought it with the motherboard, but if we were to just look at the CPU, based on pricing I had at the time, it would have been about $100 for the pair. Which, I mean, as I said, that means 2 times 8 cores, that gives us 16 cores, and these have hyper-threading, as most Intel CPUs do, and I guess all of them basically in the server space. Then it's an excellent value. So that gives us 16 cores with 32 threads for $100. Yeah, beat that with your Ryzen chip. I don't think you're going to be getting that level of, modularity and the sheer number of cores. Now, compared to the 2620, the base level would have had a base. I think those have a core clock that's really low. It's in the 2.2, 2.3 range or something. These are a lot better. If I recall, the 2650s have a base frequency of 2.6 gigahertz, and these can turbo up to 3.4. Now, if you have seen stuff like Alder Lake, you might be like, oh, but modern CPUs can do 5 gigahertz. And consider this, when these came out, the top of the line 4770K, which would have been the Haswell Core i7 part, would have been able to do, I believe, 3.4, 3.5 gigahertz base as a reference. So these are definitely slower in terms of clock speed. And that's generally what happens with Xeons. You're going to get slower cores, but more of them. And that's also partially to keep the thermals down, because these have a 95 watt TDP, but I've never really seen them heat up. They tend to be pretty cool chips, actually. I don't think I've ever maxed out my heat sinks, and looking back, they were complete overkill, which is, I'll present those in a minute. So 2.6 to 3.4 gigahertz. Of course, that kind of depends on your motherboard. And the other thing to consider is that each of these CPUs should have 40 PCI Express 3 lanes. So that was actually a way that Intel differentiated their Intel Extreme Edition i7s back in the day, was by the number of PCI Express lanes. So the entry level would have had something like 20-something PCI Express lanes, I want to say. So because for the longest time, consumer CPUs only had 16. So that meant that if you have 1 GPU, you're getting 16 lanes. 2 GPUs, you're getting 8. 3 devices, you're getting 8, 4, 4. 4 devices, you'd be getting 4, 4, 4, 4. And I guess 4 was only ever used for 4-way SLI, but I don't think 4-way SLI has been a thing since, well, I don't think the 700 series even officially supported it. They did 3-way, but people did it anyway. It's not like it was economically viable to do so, because you don't get very good scaling as you scale up the number of GPUs with SLI. Scanline interleave, is that what SLI is to stand for? Interweaved? Anyway, yeah, so these have 40 PCI Express lanes, which is what the top and Extreme Editions did. Now that might be important because, I mean, on my motherboard that doesn't particularly matter, but on some motherboards, particularly workstations, it meant that you could add in a lot of expansion cards. I'm going to be quite limited in this case, and that's going to come down a bit to my motherboard choice. For RAM, so LJ1150 CPUs pretty much always use dual channel memory. That means that your motherboard, while it might have 4 slots, it's only going to be, it can read and write to 2 separate memory modules at the same time, basically, right? So without giving away my RAM particularly, if I had one-way memory, here's a memory, here's some RAM, I'd be able to read and write to this at the same time. So my speed is limited to the speed of this. If I have two-way, I can then read and write to both of these at the same time. So that boosts the memory bandwidth available to the system. In this case, LGA 2011 CPUs pretty much always had, I want to say that they were almost always quad channel. So that meant that on a motherboard with 2 memory slots per channel, you'd have 8 slots. And if you look at some motherboards from the Extreme Edition days, I'll have some on screen right now, you will see that many of them did indeed have 8 memory slots. So quad channel memory would mean that on a large motherboard, I would have had all 8. And once again, if you're going dual socket and you're going with the massive motherboards, you will get all 8 as well. But in my case, because of some size constraints, I'm only going to have one memory slot per channel. Now, these are DDR3. DDR4 would have come out the generation after this. So Intel Haswell was DDR3. And I mean, of course, in my mind, DDR3 is still... Well, my first computers used DDR, I guess the triple channel. The first desktop I ever used triple channel memory. And then my laptops all use DDR2. So of course to me, DDR3 is like, whoa, we can have more than 2 gigs of DIMM or 4 gigs of DIMM. Holy crap. We can have 8 gigs of DIMM now, you know, it's amazing. But of course, DDR4 was then seen as like new to me at the time, and now DDR5 is out by the time I'm recording this, so maybe I'll upgrade to DDR4 in a year or two. But anyway, these are DDR3. Now DDR3 can be had for, I would argue, pretty cheap on eBay, and for most people, I think it will be fine. Of course, when you see the speeds, you might be like, oh, you know, it's a lot slower. So DDR3 base speed was 1066 mega transfers per second. Thank you, Mr. Dr. Ian Cuttress, for his video that explained that it's not megahertz, it's actually mega transfers per second. So we went from, because it's DDR, so since it's double data, it sends it on both the rising edge and the falling edge. But anyway, that's a separate discussion. So DDR3 base speed would have been 1066 with many platforms sorting 1333. These CPUs will officially do, I believe, up to 1600 or 1866. Well, the documentation says 1866, so 1866 will be the maximum. I'm going to be using 1600 RAM, which is, I believe, what most supported at the time without any problems. And another point of distinction is that there are 3 types of memory, right? You have your non-ECC, unregistered, unbuffered memory. But then, which Intel Core series, it was, I'm not sure if Alder Lake is restricted, but at the time, every consumer line of Intel CPUs would have been restricted to non-ECC memory. ECC being error checking correcting. So ECC can automatically correct single bit errors in RAM, and it'll detect 2-bit inconsistencies. So ECC is great if you're doing mission critical applications, because, you know, you might have a random solar flare hit or something happen that causes a bit flip in the memory, and ECC will ensure that that does not happen. All right, so Intel CPUs, as I said, Core series did not support ECC, so that was a feature saved particularly for their Xeons, because Intel didn't want to, I guess, cannibalize the workstation market with the consumer CPUs. So these CPUs will support ECC, both buffered, registered, and basically any variety you can think of. So that means that using registered DIMMs, you can actually get probably up to hundreds of gigabytes of memory instead of the theoretical maximum, which is, you know, something which is cool, because you can use load-reduced DIMMs. Of course, those will be insanely expensive, so I wouldn't recommend you do it, but it is an option if you require tons of memory and you don't necessarily want to spend tons and tons of money on a new system. But the sweet spot would be, I would say, since you have a platform that supports ECC memory is usually cheaper on the second-hand market, just because people can't use it for their regular desktops. So you can kind of tap into this untapped market, I guess, or untapped supply of RAM that comes from workstations and servers, because all that ECC stuff, well, normal people can't use it, but now you have a CPU that can. So I'd recommend going for it. And also, you might as well get the reliability boost that comes with it. So that is, I guess, a quick outline of these CPUs. If you really wanted top of the end in this generation, you can go for 2697 V2s. If you start going to V3s, motherboards start to creep up in price, I would say. So V2 still gets you 22 nanometer. It's not like V3 is a necessarily large improvement, but I guess the 2620 V3 stepped up to 8 cores as the base instead of 6, so maybe that's something. I'd like to mention that these CPUs aren't dead by any means, right? In a lot of markets, particularly ones you can find on places like AliExpress, it's very common and quite popular that people take these CPUs and pair them with remanufactured motherboards. You might say, well, remanufactured motherboard, what? And what I mean by remanufactured motherboard is essentially they will salvage the old chipsets that Intel no longer manufactures off of waste boards that might be broken, and they will solder it on to new motherboards. So you'll see lots of these deals where for $100, $200, you can get a full CPU, you can get CPU, memory, motherboard, all in a combo. And there are, of course, similar things that exist for third generation. Now, if you're going to buy two CPUs, I suggest that you look for a matched pair that will ensure that you'll have the smoothest compatibility if both CPUs are from the same lot. Just like how if you're going to reuse lithium-ion batteries from a laptop, you'll want to use the ones that have always been charged and discharged together, just for that added stability boost. All right, that's our CPUs. Let's go on to the next component. When I said this was going to be a long video, I was not joking. All right, I've had to drop the resolution on that camera, so hopefully my dual angle setup here continues to work fine. I just have the top down one, just in case, my main camera here decides to bug out. So next up, I want to talk about the motherboard, because this is probably going to be one of the harder components. And you really have, once you've settled on your CPU, that's going to kind of restrict your options, right? So of course, I'm not talking like AMD versus Intel, or it's more so consumer versus this workstation or server chip motherboards. So I'll talk about why I chose this motherboard in particular, and we'll talk a bit about this era of boards in general. So if you've decided that you want an LGA 2011 system, you kind of have two options. You can go for used motherboards, or you can go for the Chinese remanufactured motherboards. Now, for a desktop, the remanufactured motherboards might look like an okay deal. You can get single socket ones that are MATX. And by the way, if you're curious, the reason they're usually MATX is because it's usually the cheapest. Because MITX or ITX, you'd be paying more for the compactness, and ATX, you're paying more for, more copper. Well, they'll do MATX, and they'll throw in some features that the originals never had. They'll maybe throw in some USB 3. They'll throw in NVMe slots, right? They'll throw in these bells and whistles. But at the end of the day, it is a no-name motherboard off a remanufactured chipset. In my mind, I would rather trust someone like Supermicro than I would any random one of those to stay on 24/7, which if you're building for a workstation, very well might be the case. Now, if you're building a cheap gaming system, absolutely you can go for one of those. I would say that those are pretty much insane value. Particularly if you're getting CPU, motherboard, RAM, everything all in for $100, that is an exceptional deal that'll be, hard to match in many places. So you could go for it in that case, but in this case, I'd rather go for name brand. And of course, when you're talking name brand, you're going to be limited, right? So you've got Asus, they do server boards, Gigabyte to some extent, Supermicro. You'll have Dell, HP, but those will usually be more in their integrated stuff. You have Tyan, and I guess you have ASRock Rack as well. Those are kind of your main things. Asus and Supermicro tend to be more common in my experience, at least on the used market. So, of course, that once again limits your choices a bit. Now, majority of the boards you find on the used market will be, if you're looking dual socket, will be massive. They're going to be a lot larger than this. In fact, this board is, I believe, one of only in Supermicro's range that fits in a regular, ATX-ish form factor. And once again, as I said, I had to mod my case to fit this in to some extent, just because of standoff locations. But this isn't SSI, CEBEEB or anything like that. This is EATX. Now, compared to a normal motherboard, normal case motherboards will have, and roughly around here-ish, this one does continue a bit further on because, you need to have two massive CPUs. So it is, of course, a bit bigger, and case compatibility will vary. Actually, for this build, I originally wanted to use a Cooler Master NR200, I believe, the big ATX one that has 8 hard drive slots or something like that, and they're all spacious and all the hard drives get good airflow. But that case has the motherboard tray embedded into it, and it means that this edge of the motherboard actually interfered with the side of the case. So I had to go back and reuse my old case. It has some downsides, and I'll get to those when I talk about the case. To get a compact board, you're giving up a couple things, right? The biggest thing you're giving up is you're going from having 8 memory slots per CPU, so 16 in total, to only having 4 per CPU, 8 in total. So whereas before you could run 2 sticks and 4 channel, so 8 memory slots, and you'd get high capacities. You'd be able to get 64 gigs just in regular RAM per CPU. Here, using normal DIMMs, would be only limited to 32 gigs per CPU, so 64 gigs in total. And if you want a lot of memory, that's something to keep in mind, because it is a trade-off. Another trade-off is, look where notice how we don't have as many expansion slots. You've got 1, 2, 3, 4, 5, 6, and I'll talk about for that. Whereas a normal system would have 7. But there's no way that Supermicro could have really fit a 7th slot, because that's where like even in this tiny space between the memory, they've jammed in like power delivery. So it's a very, very jam-packed board. If you're going to go LGA 2011 and you've chosen you're going to go with a used board, there are two kind of series of boards you're looking at, right? There's the workstation stuff and the server stuff. You can generally tell them apart. Well, normally workstation stuff tends to be more single socket, but I've seen dual socket workstation boards as well. Ways to differentiate. Workstation boards will almost always have full X16 PCIe lanes. Usually they'll have fancier like black PCBs or whatever. I don't particularly care about the PCB color. But they'll have your creature comforts. What I mean by creature comforts. The biggest difference of this motherboard will be visible when I turn it this way. Look at this I/O. A workstation tier motherboard would not have this I/O configuration. So let's work through the I/O. We've got serial, Ethernet 1, but this is actually just a management port, 2 USB 2.0 off the chipset, another 2 USB 2.0. Actually, these ones don't work because I blew the fuse on them, because once again, that's something to pay attention to. Then these two are your actual working gigabit NICs. There's also a version of this, I believe, with 4 dual, and then VGA. Yeah, but Tony, I thought you said that these Xeons don't have built-in graphics. They don't. This board actually has a built-in GPU so that you can use it with basically over like remote desktop over the management, but this just hooked up to it. It's a is it some Matrox chip? It's a 32 megabyte VRAM GPU. Only really meant to ever show a terminal, and it works great for that. Linux will show a terminal to it, no problem. But then again, Linux will also boot off the serial port, which I've done a couple times, no problem, where you can just log in over serial. Well, serial loopback, I haven't used this physical serial port. I haven't had any need for it. What's missing here, right? Well, I can say a couple things. First of all, where is USB 3.0? I don't see any 3.0. You know, what if I want to copy something off a flash drive quickly? Well, guess what? You're not doing that. 2.0 only in this case. And I'll show you how we can get around that. But again, something to keep in mind. Another thing, where do I plug in my headphones? Well, most motherboards have a Realtek ALC 1150 or Realtek 892, ALC 892. Just to provide audio, right? Your typical 5.1 surround, so 3 jack or 5 jack audio. But in this case, this is meant to go on a server. Why on earth would you want a headphone jack on a server in a rack somewhere, right? It's not built for that purpose, so there's not going to be audio inputs or outputs on this board. And once again, I'll show you how we can work around that. So that's your main difference. And I guess most workstation boards would have had the dual LAN, so I don't think that's necessarily the biggest difference. But for example, another big difference is the inclusion of management. Now, I see this as a feature rather than a drawback, but of course, you might have a different experience with that. And I'll talk about why I think it's a feature. It's very good if you're not necessarily going to be at home, because IPMI essentially uses this Nuvoton chip on here, which is a separate CPU on the board. And it will let you work in conjunction with Intel Management Engine, which I still think is a backdoor. But anyway, it'll let you work together with the Management Engine to power on the computer if it's powered off, BIOS upgrade, send stuff straight to the serial. So remote control, remote desktop to some extent with the built-in VGA, so on and so forth. So it's very useful. All right, so let's do a close-up through some of the different components of this motherboard. So let's start our tour up at the top. So these are dual, as I said, dual LGA 2011 sockets. This is pretty much what you would expect for this board. And even here, there's a couple things you need to pay attention to, because there are two types of LGA 2011 sockets. There's a square ILM mount and narrow ILM mount. Here's how you can tell. This board has these 4 round holes here, 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 and here for a cooler to screw onto, and correspondingly in these 4 corners. This is called a square ILM mount. This will determine your cooler choices, and I can tell you that there are a lot more square ILM mounts than there are narrow ILM in terms of coolers. But a lot of motherboards, to save space, don't use the narrow ILM mount. So if you're using narrow ILM, you're going to have to make sure. Again, see, there's a lot of, I guess, little things to pay attention to. So square ILM, maybe more rare on the motherboard side, but way more common in terms of coolers, and you'll be able to reuse a lot of existing coolers because most of them will at least support the layout. So that's one thing one fundamental difference to note. I'll of course also mention that these sockets are slightly more unusual. There's dual retention arms, but I'll get to that when we get to the building the computer part. All right, now let's focus at the VRM, because this is what I was saying is an important bit. So a lot of consumer motherboards have extensive, massive, VRM heatsinks, so they will not suffer from this issue. And they'll all have their cooling, but here we can literally see the chokes out in the open and some MOSFETs underneath these teeny little like heatsinks here and here. In fact, there's MOSFETs here that don't have heatsinks at all. So here, so it's definitely built for a different type of system, because you need to remember that a regular computer motherboard is built around the fact that you're probably going to have a tower cooler, and that's not going to put very much airflow over these. So you need to have a large thermal mass to at least cool the VRM. But there's a slight problem, which is that a lot of server motherboards expect you to put this in a chassis. And remember, in a server system, you'll just usually have passive heat sinks over here. That's why these are in line like this. You can have these heat sinks like that. Then you'll have a heat sink with its fin like this, and then heat sink with its fins like this. And then you'll have this chassis have these high RPM, think like Delta, think Linus Tech Tip's Blowimatron style fans, where they'll sound like a jet engine, but it's going to be in a rack somewhere. No one's going to hear it, so they can absolutely get away with that. All right, I moved the mic, so hopefully that picks me up a little bit clearer now. So these are expecting these high amounts of airflow all flowing in this direction by the way of the chassis. It's expecting that the air is just going to go like this because of these massive high RPM fans that would be mounted on this side of the motherboard over here. But of course, that's not going to be the case in the system. So this motherboard will probably be cooking a little, because it wants a lot more airflow over here, but it's not going to be getting it. So it's something that you'll want to keep in mind. And this might be why something like a flower style cooler might be a better idea for a system like this, just so that you can have at least some of the airflow that's getting pushed onto the CPU go and cool these, because in my experience, these get quite hot. Another thing to, I guess, pay attention to, you'll notice that if we look at the power, there is a 24 pin, just like any modern motherboard. I guess 20 pins are a thing of the past, but then there's dual 8 pins. Because we have two CPUs, each CPU needs 8 pins, and remember, a 4 pin would give you 75 watts, an 8 pin can give you 150, which, by the way, is similar to the GPU power scheme, where 6 pin PCIe will give you 75 watts and 8 pin will give you 150. So you'll need to make sure you find a power supply with dual EPS 12 volt connectors. And once again, pay attention. These are not the same as, like, you cannot jam like a PCI Express power connector that would go into a graphics card. Yes, you can buy adapters that will convert those over into this, because it's the same 12 volts, it's just a different pin out. But if you jam one in here, you will cook your system. So make sure you don't stuff it in, because you can force it in, but you really shouldn't. All right, next let's look at the RAM. As you can see, we have a total of 8 RAM slots. As I said, this is half of what you would expect a system of this caliber to have, but we are space restricted on this motherboard. So you have these 4 slots for this CPU, these 4 slots for this CPU. And in this case, the motherboard's Supermicro has this very, very handy quick reference handbook that I will link in the description. This will tell you exactly which order you will want to populate. So if this focuses, you'll want to populate it in this order for each CPU. So that's the RAM slots, and here's the order you'll want to fit it in if you have 1 CPU, 2 DIMMs, and in this case we're going to have 2 CPU, 4 DIMMs. So I'll get to that when we get to building the computer. Another thing to note, for example, is that these are meant for 4. There are a lot of fan headers on this motherboard, right? There are 1, 2, 3, 4, 5, 6, 7, 8, at least 8 fan headers on the motherboard. And of course, those are going to be meant for the more server-style fans. Now, a thing to consider is that this motherboard doesn't have voltage control. So if you plug in a 4-pin fan, it will be able to get the RPM. I'm not sure if I published my video on 2 versus 3 versus 4-pin fans used in computers yet. If I haven't, that's apologies on me. That's something I intended to do, but I don't think I ever properly got around to doing. But if you're using a standard 3-pin computer fan, such as here's a Corsair one. This actually has broken bearings, so I don't really use it, but this is a 3-pin fan. If I plug this into this motherboard, well, this motherboard can't do analog voltage, so it's not going to get speed control over this fan. So because the way fans work is 2-pin fans will just run at what speed the voltage defines them to run at. 3-pin fans, the 3rd pin is used for a tachometer to give the RPM. But they still work on the same principle. The motherboard has to physically change from 12 volts to 9 to 6 to 5 to start and stop the fan. Whereas with 4 pins, it always gives 12 volts, and it will use pulse width modulation, where it turns the signal on and off rapidly on the 4th pin to tell the fan what speed it should run at, because motors can't, start and stop that fast. So they'll have no problem providing enough current. They're made for high RPM fans. But if you use 3-pin fans, you won't get speed control. Once again, there's ways around this, and I will show you. In fact, I'll show you right now. A simple way is through a random adapter that's like this, where you can have fans connected over here. See if the camera focuses. All right, now that we're focused. So your fans will connect to these ends here. And essentially, this just provides you with a speed control. So here is a switch where you can change between 12 volts off and 5 volts. And the way it gets that is just with a Molex connector. So Molex goes 12 volts, ground, 5 volts. So by just connecting the fan to either those 2 pins or the other 2, you can get rudimentary 2-speed control. And I have a couple of those adapters throughout my case, so I get some fan control. Alright, so those are the fan headers on this motherboard, and we can zoom in to take a look at them. They're labeled 1, 2, 3, 4, and there's also labeled A and B. I suppose A and B were meant for CPU heatsinks. So that's that. Alright. Oh, I guess I forgot to mention this. My motherboard of choice is the Supermicro X9DRL-IF. Once again, that's the X9DRL-IF. So the X9 is the generation. They have X8, which were the motherboards that came before this. They have the X10s, which are the motherboards that came after this. You get the gist. There's X11s, so on and so forth. The DRL-IF, the DRL is the version, basically this motherboard, and the IF is a variant. So there's 2 variants of this board. There's the IF and then there's the 3F. Their main difference is down here. I'll talk about that. Actually, let's talk about that right now. So let's talk about SATA. This build, as I said in the start of this video, is well suited for NAS applications or for use of the server. And this is part of why, although I think the 3F might be a better motherboard depending on what you are doing. So this motherboard has a total of 10 SATA ports. Now, something to remember is that in Ivy Bridge and Sandy Bridge, before Haswell, motherboards only had 2 SATA 3 6 gigabit per second ports. And then your additional 4 ports would be SATA 2, which is 3 gigabits per second. For a hard drive, that really doesn't matter. I don't think hard drives, well, your theoretical bandwidth limit on SATA 3 is about 500 megabytes a second, so on SATA 2 it's about 250, and a hard drive's probably going to basically just hit that, so you'll probably be fine. But, so as I said, the chipset provides 2 SATA 3 and 4 SATA 2. So in this case, you will notice that these 2 white SATA 3 ports are the ones that are 6 gigabits per second from the chipset. So these are the ones that you should use, for example, on your boot SSD. Given that you will probably want to have maximum performance. Now, beside that, these 4 are SATA 2 3 gigabits per second that also come from the chipset. You can see from their kind of different shadow that, so you can probably see from this bank of 4 is different than this bank of 4. So this first set of 4 SATA ports This is also common to all variants of this motherboard. These 4 come from the chipset, so they're a good use for plugging your normal hard drives to. Maybe you can consider RAID on them. I haven't tried. I usually prefer just using software RAID through the means of something like an HBA, but it's something to consider. If you really needed the more bandwidth, of course there's ways around that, and I will get to it when I talk about expansion cards, something like this perhaps, with more SATA or SAS ports. That's a sneak peek of what's coming. But yes, you get 4 SATA 3 from the chipset, and then these 4 are from the additional chipset on this board. So this 4 is technically separate from this 4. They all will basically work for your applications. If you were to do something like hardware RAID, you will want to pay attention to it because there are limits. You won't be able to go between those 2 chipsets. And it looks like my first camera is out of memory, so we'll be down to just 2 camera angles for this portion of the video. Alright, so we have 2 of the SATA 3, 4 SATA 2 from the chipset, 4 SATA 2 from the other chipset. Now, this is the big difference between this board and its neighbor, the X9DRL 3F. That's because if you look carefully on the motherboard, alright, so if you look carefully at the motherboard, you'll see that these there's 4 positions here for potentially more sockets. They're labeled SAS 4, 5, 6, and 7. Now you might be wondering what's up with those. Well, that's for the X9DRL 3F version of this motherboard. So you'll notice that these 4 say SATA 1, SATA 2, SATA 3, SATA 4, and then this says SATA 5. SAS, SATA. As I said, the big difference between this motherboard and its neighbor, the X9DRL 3F, is the configuration of the storage ports. So in this case, we have 2 SATA 3 from the chipset, 4 SATA 2 from the chipset, and another 4 SATA 2 that's coming from the additional chipset. But the neighboring version of this motherboard would have had these just as normal, but instead of these 4 SATA ports, you would have had 4 SAS ports plus another 4 SAS ports. So that's the big difference. You are getting a total of 6 SATA on that board, 2, 3, 4 SATA 2, and then a total of 8 SAS ports. And you can see that if I bring out the manual. And you can see that if I bring up the manual for this board, SAS, SATA. Alright, so why would I bring this up? Well, that's because if you're planning on getting your drives from enterprise surplus or used enterprise drives, a lot of the cheaper hard drives out there will be made for SAS. So consumer hard drives use SATA, serial ATA. A lot of professional workstation or enterprise hard drives will use the SAS protocol, serial attached SCSI. So in that case, you need to be careful and make sure that you have a drive. If you're going to buy a SAS drive, that you have SAS ports on your motherboard. You can plug SATA drives into SAS ports, but you cannot plug SAS drives into SATA ports. So if you buy a SAS HBA, it can run both SAS drives and SATA drives. If you only have SATA ports, though, you will not be able to run SAS drives. That being said, they are surprisingly similar. They both use the typical SATA cables that we both know and love. If you don't break the clip off, at least by accident. So you don't need new cables necessarily unless you're using SFF 8088 and 8087, which are like the 4-in-1 cables that can carry 4 SAS lanes. In that case, yeah, you'll need cables, but otherwise it's basically very similar to this. So that's the SATA port of this motherboard. Alright, next up, let us cover one of the last remaining things, PCI Express. Save the best for last. So, because this motherboard is so restrictive, particularly in I/O, we are going to need to make good use of these connectors. So there's a number of things that are missing here that at least I would like to add to daily drive this, and I do daily drive this. Graphics card, for example. Really, one VGA port at 1024 by 768. We're going to want a GPU. We're going to want USB 3. We're going to want audio. If you're using this as a NAS, you might skip the GPU. Instead, you will have different requirements. For example, a good use case for a server might be to add a SAS HBA, host bus adapter. So that way, or a RAID card, so you can have more drives connected, particularly because, as I said, this board doesn't have SAS. So you can have a SAS HBA hooked up. And then another option is you can have, this board doesn't have any way to do M.2. But if you know a thing or two about M.2 and NVMe, you'll basically just know that M.2 is just PCI Express, or at least NVMe. So, you might then get a little interested, and then you can, of course, pick up an expansion card like this, which will allow you to put an M.2 SSD into this computer. Now, you won't be able to boot off of it, but I'll talk about that when I get to expansion cards. But it is a choice so that you can have a nicer, for example, high-speed cache, particularly if you're going to use something like ZFS, because ZFS can do multi-tiered caching. You can have your memory cache, then your SSD cache, then it'll go to the hard drive. If all of those, if it cannot find the file in any of those. This motherboard has 5 PCI Express lanes and 1 PCI. Now, if I look at the manual, well, this is not the manual, this is just a quick reference guide. They label these as being from the bottom up. And in this case, Supermicro has made an interesting choice because all of these will get their lanes either off the chipset or off CPU 1. So, looking here, this is CPU 1, this is CPU 2. This CPU is going to be doing the heavy lifting. GPU, any PCI cards, they're all going to be talking to this CPU. So if a program that's running on this wants to send data to your USB card, it has to send to this, then this can relay it. And if you download the full manual for this, maybe I'll include a screenshot. There is a block diagram, and the block diagram is this CPU is also the one connected to the chipset. So if this wants to do anything here, you'll see it. And in fact, I thought this wouldn't really make a big difference, but if I run a program with 32 threads, you will see that half of them will only get about 80% usage, and that's because those constantly have to pass back and forth between these CPUs. So something to consider. You'll want to make sure that your operating system is aware of NUMA nodes. Basically, this means that if I'm running a program and the program wants 6 threads, you want to put all 6 of those threads on the same CPU. You don't want to split them across the 2. And here's why. This CPU slot, I'm getting slightly distracted from the PCI comment, but this is really important. This CPU can talk with these memory slots. This CPU can talk with these memory slots, right? So if I'm running a program, my program lives in memory, and all of the data that the program uses is also going to be in system memory. So this CPU cannot access something here. It has to talk to this, which then fetches it and sends it over the interconnect. That's slow. So if I have a program that wants 6 threads or 8 threads, you need to make sure that all of those go onto the same chip so that it can always access the RAM straight off the CPU and it doesn't have to do this back and forth. Now, a number of programs are not aware of this. So they'll see that you have 32 threads, 8 cores, which is 16 threads. And so they'll launch in 32 thread mode. But that's actually not optimal. It would be better if you had 2 different programs that were using 16 threads each. And this way you wouldn't have had to bungle around and keep sending stuff back and forth in memory, which is kind of inefficient. But that's not a complaint. Now, if you're going to use this as a Windows system, just know that you can't. Windows 10 and Windows 11 do not support multi-CPU configurations. They do not support multiple NUMA nodes, at least not the last time I tried. However, Windows Server does, or at least Server 2012, which was the only one I could get a student license for at the time. So if you're going to use a dual CPU system, you will need Windows Server. I don't know if Windows 10 Pro supports it, never tried it. Now, once again, if you're going to use that, make sure you take that into account because there is a pricing difference there. Linux, the Linux kernel is NUMA node aware, so if you're using Linux, you will have no problem using both CPUs simultaneously, or at least none that I encountered. You can use task set, for example, to make sure certain programs only use certain CPU cores as well. So that's all stuff that can be configured. All right, back to what I was talking about, which is PCI Express. So my point was, all of these PCI Express lanes come off CPU 1, so it's just something to keep in mind. So you don't get... The PCI Express lanes on this chip, the second CPU, are kind of wasted, because each CPU has a total of 40 lanes, which would have been very nice. But in this case, they don't. And Supermicro has also made, I guess, I mean, it's not that bizarre when you consider their space constraints, but they went for X8 slots. They could have gone X16, right? And if you look at workstation motherboards, particularly single CPU ones that aren't space restricted, you'll notice that they usually have CPU 8 RAM sockets, and they will use PCI Express X16, and that's just because for things like GPUs, X8 really won't cut it. Now, I can see why they might have gone for X8, because a lot of server components, NICs, HBAs, these are all made for X8, so these will slot in perfectly. And I have in my current computer that I'm using as a NAS, I have extra NICs installed, and those are also X8, and I guess one of them is X4. So it makes sense in that regard. You don't see X16 as much, but it means that you have to be careful. For example, I wanted to get an M.2 riser with 4 cards on it, and I couldn't. One thing to keep in mind is that this motherboard does support PCIe bifurcation. So you might be wondering, what the hell is PCIe bifurcation? It's basically the act of using this X8 slot as X4, X4. Why is this important? Just because it's useful for cards such as this one, where you might want to connect 2 M.2 SSDs, right? And if you have bifurcation, this will mean that you can have 4 lanes 0 to 3 going to one card, and lanes 4 through 7 going to the other card, which you wouldn't be able to do otherwise. So that's PCIe bifurcation. However, I did not get that card working. I don't know if it's a problem with the motherboard or with Linux. If I enable bifurcation 4.4, it detects SSD that's on lanes 4 to 7. If I don't enable it, it detects the SSD on lane 0 to 3. I was never able to get it to detect both SSDs at the same time, which is very, very bizarre. Now, a good thing about PCI Express is that it can both scale up and down. You can plug an X4 device into an X8 card. You can plug an X16 card into an X8 slot. PCI Express can be scaled up or down. I can plug an X4 card, no problem, into this X8 slot. I can also plug in an X16 card into an X8 slot. Now, Supermicro has taken measure of one thing, which I would have hacksawed otherwise, which is, if you look carefully at the top slot, you will notice that it has an open end, whereas these ones do not. These ones all have a closed end. This open end is important because it means that I can plug in an X16 card, such as a graphics card over here, without having any issues, because as I said, you can plug X16 cards into X8 slots. So in this case, it is very important for that use case, just so that you can have an X16 card in an X8 slot, which would not have been possible otherwise. So this open-ended slot is going to come in useful because this is the slot where you will have your GPU. Now, an unfortunate side effect is that by having your GPU, you're going to be blocking this slot underneath it. And let's talk a bit about the wiring of these. So let's talk a bit about the configuration of these PCI Express lanes. So there are, as I said, 5 PCI Express and 1 PCI, and let's talk a bit about each of them in a bit more detail. So this top one is going to be PCI Express 3.0 by 8. So I can plug in any card, and because it's an open end, I will be able to plug in my X16 GPU. This slot and this slot are technically kind of combined in the same X16. This slot is independent, but it's also technically a subset of an X16. I'll get to that. So this is a Gen 3 by 8 connected to CPU 1. This next slot is also a PCI Express 3.0 by 8. This one is also a PCI Express 3.0 by 8. Now, that's if you're counting 8, 16, 24 lanes. So we should technically be fine, right? However, this next part is a PCI Express 2.0 by 4. Now, if anyone heard that, you should have like alarm bells ringing in your brain, because usually in Haswell or Ivy Bridge systems, if you have PCI Express 2.0, it's coming from the chipset, not from the CPU. And that's exactly what's happening. So this is PCI Express 2.0 X4 from the chipset, not from the CPU, so higher latency. And you're going to get less overall bandwidth. So something to keep in mind. Next up is a PCI slot. PCI, for those of you that don't know, is basically the predecessor to PCI Express. And there were, I guess, 2 slots on computers. You had PCI for general accessories, modems, NICs, some USB cards. And you had AGP, Advanced Graphics port for graphics cards. Now, of course, now PCI Express has taken over everything. But there is one thing to note. There are two types of, there's actually a couple types. So this is a 32-bit PCI bus. So the main difference is that PCI Express is serial. So there's 1, 2, 4, 8, 16 lanes, so on and so forth. Those are the number of lanes and serial that you're giving it. PCI is parallel. That means that if I had multiple PCI ports, all of them would be sharing the same bus. So when one card is talking, the other one can't talk at the same time. It's a shared bus. This is a top tier, non-sponsored, horrible screwdriver. It's not even magnetized properly. Anyway, a 64-bit wide bus would have been a lot longer slot that you would have seen. Now, even in 32-bit, there's two different types. This is a 3.3 volt slot. How do you know? Because notice how the notch is here. PCI was, so this middle portion is data. If you have the notch here and you have a little finger that sticks out on this side, that means you have a 5 volt slot. If the notch is on this side and it sticks out on here, that means you have a 3.3 volt slot. If it sticks out on both sides, that means you have a universal slot. So why does this matter? Universal PCI Express cards that have both the 3.3 volt and 5 volt, so they'll have dual legs, and I'll show you an example of one. For example, this card. Notice how there is the data portion. There is the data portion in the middle. These are for 3.3 volts. And these are for 5 volts. So this would be able to work in this motherboard, no problem. It would also work in a 5 volt motherboard without any problems. However, I used to have a 5 volt card that I wanted to use on this computer. A 4-port capture card. A Connexant Fusion 878, also known as the Connexant 878, also known as a Brooktree BT 878, which is a TV tuner / 4-port composite capture card that I had, and that was a card that I wanted to use here so I could connect composite cameras, so that I could, use OBS without having to use janky USB capture cards. But alas, that won't work because it's only a 3.3 volt motherboard, and that is a 5 volt only card. So it has the leg here. It will not fit in the slot. So that's very unfortunate. So it's something to note. Make sure that the accessories you're planning on using are compatible PCI 3. Now, I suspect that many viewers of this channel will not have any PCI devices. But I will show you why PCI devices can be very valuable, especially when you're limited like this. And finally, let's get to the last PCI slot. This is a PCI 2.0 X1 coming off the chipset. So this is great for, I guess, random things like a Wi-Fi card, or I'll show you what I use it for. But yes, that's your final PCI slot. So I was saying something about in the grouping of these. In the BIOS, these two slots, they're numbered 4, 5, 6. So this is slot 4, slot 5, slot 6. No, I'm guessing the reason that they couldn't pull more is just because of like trace limitations, maybe. Because I guess if they wanted, this could have come off the CPU. There's enough lanes for it. I don't know why they chose to do it, especially because the BIOS has an option for like slot 3 and slot 4, slot 5, slot 6. So I'm guessing that was the plan at one point, but I guess it never happened. And just to confirm my findings, here is the board showing CPU, PCH, PCI, and that one's also PCH being the chipset. So these two slots are kind of grouped together. They're technically, I guess you could make it an X16, but they're by default bifurcated into X8, X8, which makes sense because that's how it is in the hardware. Now, as I said, this motherboard can do PCIe bifurcation to do X4, 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 X4 out of all of these. So that might be something you prefer. Of course, I had a GPU in here, which means I pick up this card so that M.2 card could only go in this one. And maybe it would have worked in these top two. I don't know. I haven't been able to try it because, well, the GPU takes it up. And that's why I said it's so unfortunate. I really now, I'm considering dremeling a hole in the side of the case so that I can mount the GPU sideways with a riser just so I can plug a second card into here. Because you've only got 3 PCI Express 3.0, and there's so many things you can add to this board. Like, it's flexible enough, but it's such a shame that you can't, because the GPU is just going to take up these two, and then you got what, 3 WinP ports. One of them's a PCI. It's very limited with what you can do with that one in terms of bandwidth, and so is the X1. So I mean, that really only leaves you with these two, and then you kind of have to be picky. For example, there are 2 cards that I own that aren't in this because there is no room for them. The first one is a Wi-Fi card. Ideally, it could have fit in one of these, particularly if I could have split one like X4, X4. I have an X1 Intel AX200 card that I wanted to use. I don't use Wi-Fi, but it is useful because I can also turn it into a hotspot or whatever. It's just more flexible, right? And the second thing I wanted to do was I have a FireWire card. It's actually a PCI Express to PCI and then a PCI to FireWire adapter. But I do not actually have a FireWire audio interface right now, so that doesn't matter as much. But back when I was attending school, or high school and middle school, our audio interface was FireWire. And I also have a camera. I have a... here, I might as well grab it for you guys. This mini DV camera that I was trying to get footage off of is FireWire, right? If I pop this open, FireWire 1394, IEEE 1394. And the benefit of that is that because that's DV, digital video, if I use the FireWire card, I can get footage without the lossiness of analog copy. But anyway, I've decided that I'm not really using FireWire these days. Haven't needed it for a while, so I unplugged that to make room for more useful accessories. So once again, Gen 3 X8, Gen 3 X8, Gen 3 X8, Gen 2 X4, PCI, Gen 2 X1. And this one is open-ended, so you can plug anything. Alright, that is the PCI section. Let's get to another neat section of server motherboards, and that's this little chip right here. This is a BMC. Now, you might be wondering, what the heck is a BMC? BMC is a baseboard management controller. Basically, it's a separate CPU that takes care of the motherboard. And in this case, the CPU is on 24/7 if you choose. There's a little jumper, one of these, either this or this. The manual has a full list of all the jumpers because there are a lot of them. In fact, it's even on this page. Jumpers, common LED indicators, right here. You really should have a printout of this if you're going to work with this motherboard. So you can see clear CMOS, SMB to PCIe slots, BMC enabled, VGA enabled, GLAN 1, GLAN 2 enabled, and watchdog timer. So there you go. Because there's a jumper here, 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 here. There's a lot of jumpers. In fact, there's jumpers that aren't even documented in the like the manual has a one-line description, but it doesn't really explain what it does, which is very unfortunate. So you're gonna have to go scrolling through forums. But anyway, the BMC is used to provide IPMI. So that means that if the computer's off, I can use this to power the computer on or power it off. Another cool thing is that there's two serial ports. One of them is like, of course, beside the one on the board. It does serial loopback. So if I tell the Linux kernel, I want you to boot the serial, I can connect to this CPU, and then I can use the CPU to send commands over to my main system over serial. So this is great because when Linux is booting, it'll print out everything, and then it'll at the end it will. I can even log in, right? It's basically, think of it exactly like SSH, but instead of sending the bits and ones and zeros over the network, what serial does is serial basically just sends the bits directly over the wire. It is the predecessor to USB, USB being the universal serial bus. Just two-way communication to send bits back and forth at a given baud rate. So that's very cool. In fact, the VGA can be used with this as well, but it's using a very old Java version that I have not been able to get working. But if you do have it working, that will allow you to be able to basically remote desktop and control the mouse keyboard and see the monitor of the VGA output of the board from anywhere in the world. All right, let's take a look at some of the connections in the bottom. This is from the fact that it's 9 pins, this looks like a serial port to me, COM port, given that it's in the black housing. So COM port is basically so that you can add in a riser to have a second serial port on the board. I don't have a use for it at the moment. The one port is enough if I ever need to connect anything like an Arduino or whatever. But, it's there. I've also connected a projector on one occasion. This is JTPM. So TPM is Trusted Platform Module. Maybe the Windows 11 users would have heard of this. You can connect TPMs. That is also standard connector that exists on many, many motherboards. This is a single USB 2.0 connected off of... So there are two USB routes on this motherboard that I could tell. One of them runs these two headers and the top two USB ports and this port. And the second one runs the bottom two ports. This is why I'm especially disappointed at the fact that I blew the fuse on the bottom 2 ports, because that was on a separate USB route. Everything else shares the same route. You might say, what is a USB route? I might have made a video on this, but I don't think I ever uploaded it. Essentially, USB is like a tree. If the CPU wants to talk to a device, it sends it to everyone. And this port can't talk if someone's using this port. So the reason that's important is if you want to connect multiple cameras like webcams or capture cards, each capture card uses a very high amount of bandwidth. So each route can only run 1 or 2 of them at once. But if I had 2 routes, I'd be able to run 2 of them. VR users might have known about this for a similar reason. So that's something to note. This is just an internal USB-A. It's cool because you can use IPMI in combination with this. For example, if you have an ISO, you can mount a virtual CD or virtual DVD to boot an operating system. So you can even install an OS completely remotely. But anyway, this is important because some enterprise applications require a license key module, like a physical license key, to be plugged in at all times on the system. And it makes no sense to leave it dangling off the back of the computer. So if you're going to run software that requires a permanent license, you can just plug it in here and leave that. Now, then we have 2 headers. These are dual USB 2.0. I love these adapters for that. These are from my old computer. Essentially, this is just a... Oh, come on. This will plug into that, and it converts it to 2 USB 2.0 ports. So these used to be on a side-by-side on an expansion card, so they would take up an expansion slot. Now, of course, knowing the system, well, there's only the one expansion slot, and that's the one left up all the way up here. All the ones on the bottom I was using. And the cable is not long enough to get past the GPU and go up here. So that's why these are not in that housing. So I just leave them dangling off the side of the case like a cuckoo person, I guess. It's also really useful if you want it. If your case had front panel USB 2.0, you can connect that. Again, I'd be careful drawing too much power from these. But yeah, you can use those for that. Or if I want to get a front panel SD card reader, because my USB SD card reader is broken, so I have to connect my camera with a mini B cable, not a micro USB B. Remember mini B cables, kids? Yeah, they're lots of fun. I have to use that to get my footage off, and especially given that I have 3 cameras, and each of these 3 cameras uses a different cable. These ones, this one and this one up here, use some proprietary connect cable that can be used for both USB and for AV out, apparently. Quite bizarre. I haven't seen that before. And then this the camcorder there uses mini B, so it's, of course, it's a mix. Anyway, these were the SAS ports. Going over here, we have, as I said, there's no front panel audio because there's no audio codec, and I'll show you the sound card to fix that. And this is your front panel connectors. If this looks confusing, that's because it is. You are going to absolutely refer to this. So on this piece of paper, which is the quick reference guide, you'll notice this handy chart here. And this has the list of which connectors are what. So ground, not connected, front panel power LED, 3.3 volt standby, hard disk drive LED, 3.3 volt standby. So you can use these two for an LED, these two for an LED, because LEDs are usually 3.3 volts. NIC 1, so the first Ethernet port, second Ethernet port, or not Ethernet technically, but RJ44, whatever. Power LED. So this is blue plus for on and fan fail, red plus for blue LED cathode, power LED fail, 3.3 volt standby, and then here are your 2 buttons, ground and power. So sorry, ground reset and ground power. So that's where your front panel connectors will go, and I will show you how to connect those when we get to the building the computer part of this video. Please focus. This is one thing I liked about the DSLR that I don't like about the mirrorless, is how slow they are to focus sometimes. Alright, so that's front panel connectors. More jumpers. I'll show you the list of jumpers and posts and all the fan connectors. And I think that's about all. Yeah, I mean, as I said, my main concern with this is just that it doesn't get enough cooling in my case, but other than that, this has been really solid. And I'm quite happy with it. It's compact, or as compact as it can be. and it's been a yeah. Now motherboards, as I said, are almost always more expensive than the CPUs. So I believe I got the CPU, the two CPUs, and this motherboard combined for a total of somewhere around 350 to 400 Canadian dollars. So, given what you know about the CPUs and that they're about 120 bucks for the two, the motherboard's probably $200 to $300. And yeah, these are really wimpy. I really wish I had bigger heat sinks to put on this. Or at least I really wish I chose a different cooler. But before I talk about the cooler, let's talk about the memory. Alright, and before I move on to that, there's an I/O shield. Alright, next up let's talk about memory, RAM. This motherboard and this generation of CPUs typically is DDR3. And generally, if you're looking used, anything that you're going to be getting, any CPUs that you're going to be getting at a good price point are realistically probably going to be DDR3. So that's probably where you should focus. Now, as I said at the beginning, the good thing with Xeons is that they can work with ECC and non-ECC memory. So in this case, non-ECC there's higher competition for it because a lot of people's personal desktops and stuff also use regular DDR. Just standard DDR3 RAM, so there's it's usually more expensive. ECC is not only technically superior, it's also usually cheaper. And in my case, I bought 4 sticks of 8GB DIMMs for I believe around $80 to $90, 80 Canadian shipped. So these are some Samsung ECC RAM DIMMs. You'll know that there are 2 types of ECC because they have a very characteristic memory layout. There will either be like the typical 4 and then 4, but then they'll have a 9th memory chip in the middle for error checking, or they will be in this configuration where they will be in these groups of 4, and of course that is that way on both of the sides of the module. So 8 gigs of DIMM is, I believe, about the max for normal DDR3. Of course, with ECC, you have the option, as I said earlier in this video, if you go for load-reduced DIMMs, you can get up to like 30 or 64 gigabytes per DIMM. So you'd be able to fit like multiple hundreds of gigabytes of RAM on the server, but it's going to be slower, and of course, you're going to then have very expensive memory. Load-reduced memory usually is not cheap because it can attain those high densities that can be used for stuff like caching. So you will be paying a premium for it, so it's something to keep in mind. So if you're fine with the regular RAM, I would stick with it. So as I said, ECC has a couple of advantages. ECC can detect 1-bit error, automatically and transparently correct 1-bit errors, and it can also detect 2-bit errors. And there is a utility in Linux, EDAC util I want to call it, which can tell you how many of these it has had. And I guess it's actually a good way of checking for signs of failure, or just getting general statistics on how your system memory is doing. You have to remember, because this is a dual socket system, half the RAM's going to one CPU and half the RAM's going to the other CPU. And realistically, what I would recommend is, if you wanted ultimate performance, you should, because these are quad-channel memory CPUs, and as I said, most motherboards, bigger motherboards would have 8 DIMM slots and per CPU instead of just the 4. It might make more sense for you to get a total of 8 sticks of RAM, so you can have 4 DIMMs per CPU. This still gives you the option to upgrade in the future to double that capacity, but it also means that you'll get higher performance. In my case, I didn't want to max the system because I wanted to be able to get it. I mean, 32 is currently enough for me. I don't necessarily have a need for 64 gigs of RAM. And I reckon that if I'm doing some niche application where I do, I'll just make a large swap file for it. And I used to make a swap file on a hard drive, but I've changed that practice. I now have M.2 SSDs for that purpose, which are a lot nicer than my mechanical hard drive swap files. They're a lot faster for sure, and they don't lock the computer up for 10 minutes at a time. But that's the RAM. There's always been advice going out about whether you should have 1 gigabyte of RAM per core or 2 gigabytes of RAM per core. Honestly, it just depends on your workload. For something like a database where it's going to be caching everything, you'll want more RAM. If what you're doing is very CPU intensive, but not necessarily hard on memory, then you might not need 32 gigs. You might get away with 16. I would recommend 32 as a minimum, because remember that means you're getting 16 gigs per CPU. So if you're passing 16 gigs, the CPU is going to have to talk to the other CPU's memory. So if this is CPU 1 and it wants something off here, it has to talk to CPU 2, which can then talk to these DIMMs. So to ensure you avoid that, I would say at least have like 16 gigs per socket. But yeah, this is a good middle ground, and for under $100 last year, I'd reckon that it's probably a good deal. Now, DDR3 isn't known for being exceptionally fast. These are DDR3 1600. You can tell because they are 8 gigs, 2R by 8, PC3L, 12800R. 12800R means that it is 1600, and the timings on these are 11, 11, E20, E2D3, whatever that means. Probably a cast latency of 11 though, which is acceptable. I mean, especially for my use case. I'm not, I mean, I guess, yeah, the CPUs would have supported 1866, but I mean, my old computer had half 1600, half 1866. I think that's all right. I think the note is that these ECC memory modules do tend to heat up a lot more than their non-counterparts. One thing I guess I should say, if you're handling RAM, it's recommended that you do not touch the gold fingers like I've been doing. But just because it can lead to corrosion and finger oils will get in it, you should hold it by the sides like this. But I do as I say, not as I do. I used to, it's interesting because when I built my first computer, I used to take every single rule really, really seriously, ground yourself every 30 seconds, you know, you gotta be careful, gotta be vicious. And then at some point after I've done this tens of times, dozens of times, not 100 yet, but, and you mess with hardware enough, you realize that a lot of it's actually quite resilient and will probably be fine. So anyway, that's the memory. It's not particularly exciting. No RGB, and especially on this motherboard, you really, 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 really should not stick RGB memory into this because it's not made for it, right? I mean, it might work at the right voltage and stuff, but it's going to be pulling a lot of current, and you might end up with a busted memory slot just because the power delivery. Remember, this isn't DDR5. DDR5 has the power delivery on the memory. This is on the motherboard. So that then means that you should be careful because if you draw too much current from the motherboard, you will probably blow the fuse or something for one of the memory slots. So I would say no RGB memory. And in fact, I don't even know if the RGB memory exists. And these don't even have heat spreaders. Again, you shouldn't hold it like I'm doing. These don't even have heat spreaders. As you can tell, they're just bare dies. Honestly, it's fine. They heat up, but they're not like particularly hot. I think it's okay if you have memory that does not have the largest, like, massive heat spreader dies on them. But again, that is a personal opinion. Next up, let's talk about drives. You can't build a server and start data hoarding without somewhere to store your data. So in my case, I was going to have 4 drives in the system. Well, I have drives of different types, I shall say. And of course, exactly what you're going to use and how you want to use it will depend on your exact use case. But let's start off with the boot drive. Alright, let's talk about storage next. You can't have a server or a NAS and start data hoarding if you don't have somewhere to save your files. So let's start with the boot drive. For a boot drive, these days I always recommend an SSD. I still have the boot drive from my first desktop computer, which is this hard drive. And it hasn't died yet, so it will be making an appearance in this video in a minute. But I would recommend going for an SSD. In this case, of course, most people are going to go out ahead and, you know, they're going to recommend their M.2 Gumstick SSDs. The slight problem is, as I said, this is an older motherboard. So while you can use an adapter, such as this, to connect an M.2 SSD into PCI Express by 4, the motherboard BIOS will not necessarily boot from it. So of course there is a way around that, and what you can do, and what a lot of people will do, is you can install Linux such that your /boot partition is on a SATA drive or on a USB flash drive, and then you can have it point and then your /boot will point the root FS onto your M.2 SSD, and that's perfectly acceptable. So let me repeat that. Your computer has a particular bootloader, right? Something like Grub or Refined. And so it's going to need somewhere to load the kernel. So that's in Linux is the /boot partition. You can put your /boot partition, which is the only thing that you really need to be bootable, on something like a flash disk or an SD card. Leave it plugged into for example, you can use the internal port on the motherboard that we have. It's great for that application. And you can then use that port to do the boot, to power on the computer. And what you will do is in your bootloader, you're going to define something as your root fs. That's basically where it's going to mount /, the main file system, when it starts the kernel. If you make that equal to something on NVMe, the Linux kernel knows what NVMe is. It knows how to use it. It doesn't need the motherboard to boot off of it. So you can do that. And it's actually common on a lot of embedded devices where they will boot off of, for example, they will use either EEPROM or more realistically, they'll use eMMC as the boot drive. But then once it boots, it can switch to an SSD. I've done this on a Raspberry Pi, for example, where I put the bootloader on the SD card, but then it can boot onto something that's on an 2.5-inch SSD plugged in over USB without any problems. So I would recommend that you use that approach just because, NVMe is considerably faster. But in my case, I like the simplicity of SATA for my boot drive, and honestly, 500 megabytes per second with a SATA drive is plenty fast. I remember Linus Tech Tips did a video a while ago where they even tested the use case where higher sequential speeds would matter most. They were testing game launch times, and they tested a SATA SSD, a PCI Express Gen 3 M.2 SSD, and a PCI Express Gen 4 M.2 SSD. And the funny thing is, I believe most of their team members thought the SATA SSD was the fastest, not the PCIe Gen 4 one. So SATA is still plenty good. This was the original boot drive for this computer. This is a Samsung 860 EVO 500 gigabyte. I wish I had something like an 840 EVO or like even the earlier ones before they... this is still good. It's not QLC. It's not the QVO. It is still the original EVO series. It's not the Pro. But this is back when Samsung was highly reputable. Now, this was the boot drive on this computer from 2018 all the way up until, well, the start of 2022. Until a few days ago when this drive has seemingly stopped working or passed away. I don't know what to call it. But basically, it doesn't boot from this anymore. The BIOS doesn't detect it. I plugged it into my laptop with a SATA adapter, and it cannot get any data off of it. So I'm tempted to think that the drive is dead. And I probably won't be getting my data, but at least if I RMA it, I encrypted the drive, so Samsung won't be either. But this was the boot drive, and instead we're going to be switching to a new drive. So my new boot drive is this. All right. So this is so my laptop, as I said, was the ThinkPad E495, and that laptop has one advantage, which is that it has both an M.2 slot and a SATA slot. And a SATA slot is particularly useful for something like this, where in the M.2 slot I have my main boot drive, but in the SATA slot I didn't want to use a hard drive just because, they're clunky, and I didn't have any like 1 terabyte, 2.5-inch hard drives lying around anymore. And apparently the ones that they do make, for those that are unaware, laptop hard drives used to be 9mm, and then the SSDs are 7. But any new hard drive is 7mm, and what that tells me is that they're using SMR. And I also know that because the cache went from 16 megabytes to 128, and there's no reason that a hard drive manufacturer would bump the cache up by, many-fold, unless they were trying to hide something. And in this case, they're hiding the fact that they switched to stupid SMR drives, which means that the write speeds are going to be horrendous and blah, 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 blah. Anyway, I guess the advantage is you can get 5 terabyte drives that you can shuck out of Seagate expansions, but they don't sell them OEM, so you'll have to shuck them if you want a 5 terabyte drive. Anyway, that whole discussion aside, I had this SSD in my laptop that I had been using, and it's a WD Blue 500 gig 3D NAND. I heard that these are not necessarily as fast as a Samsung one, but it still has a DRAM cache. This is the version from Canada Computers. There is a scandal on this drive, if you are unaware. The Best Buy, really interesting. The Best Buy and Big Box store version of this drive has a considerably lower performance than the computer store version. So there's a different packaging that you need to be on the lookout for. And if you're buying this, make sure you get the good version. So that's sold at places like Canada Computers. Memory Express, I believe, also carries a good one. NCIX wasn't around when I bought this. NCIX was around when I bought my first SSD. So I guess don't consider them. But places like Amazon, Best Buy, I would be careful to make sure you're getting the good version, because they're called the same thing. It's still called the WD Blue 500 3D NAND SATA SSD. This is also same thing, 500 gigabytes. This is 1 year newer than the other one for what it's worth. But I'll be using this as my new boot drive. Probably slightly, maybe slower, but I don't think I'll be able to tell the difference realistically. just because a lot of the difference comes from those 4K reads and writes. Now let's get into bulk storage. The main hard drive in this computer will be this Seagate Barracuda Pro that I shucked out of a Seagate expansion, or Backup Plus, I forget which one. So this is a 10 terabyte helium drive, CMR, 7200 RPM, excellent, I love it. I've had very good luck with these Barracuda Pro drives, especially given my unfaithful bad end with a WD Red Plus that I'll show you that was supposed to accompany this. But so this is a 10 terabyte Barracuda Pro. These things are excellent. They are SATA AF, as the Reddit folks like to say. This is a full CMR drive, none of that SMR nonsense. See, it's always interesting to me because when manufacturers launched SMR, they said that it was a way to basically they had reached the maximum platter density that they could get. So, to make bigger drives, they were going to have to start shingling them to make these 14, 16, elusive high terabyte drives. And what's interesting is Seagate has shingled 1 through 8 terabytes is, I believe, all shingled now. But if you get a 10 terabyte drive, these are not shingled. In fact, they're not even, this is 7200 RPM. And unlike WD, where they called it 5400, but in fact it was a 7200 RPM drive using the power of the 7200 RPM and making as much power as the 7200 RPM, while only producing as much performance as a 5400 RPM, this has the performance of a 7200 RPM. This has very good performance actually for a hard drive. So, performance, you say, from a hard drive, yeah, so these things are excellent. They have, so essentially these drives work by having a platter. This is not a platter, this is a DVD. Looks like a platter though, just instead of optical, think this, but magnetic. Wow, what a shame for me to use a Taio Uden DVD for such a dumb illustration like this where it's going to get scratched. Anyway, so essentially then they have a magnetic head that goes along to read and write to it. So just like this, it's spinning. But so of course there's two times. There is, if your file is here and I'm here, you need to wait for this to make at least up to half a rotation or a revolution, or up to one full revolution to get to your file, because it's always going to run. And the other thing is the head then needs to move, and that's usually the slower part. You will hear a hard drive, clacking away, and you'll wonder, what's the dolphin doing in my computer? And it's not the dolphin; it's just the head constantly adjusting itself, seeking to where it needs to be inside the platter. You can tell where the platters are because there's the motor. So the platters are here to here. It's always impressive to me how magnificent the engineering inside these is incredible. To get 10 terabytes out of platters that are the size of a DVD, right? If this thing, I believe this has 7 platters in it. Given that they're double-sided, that would still give you about 500, over 500 gigs aside. Whereas the top of the end Blu-ray would only store 128 gigs, and those are the ones that are only available in Japan. Now, what I said this is this is SATA 3 6 gigabits per second. Hard drives, by the way, unlike the DVD example where I showed, DVDs are constant linear velocity. This means that as they're turning, well, this is interesting. This is definitely a failed burn. They start from here and they slow down when they get here, so it's always moving at the same linear speed. Hard drives are constant angular velocity. That means they always run at the same speed. This means that usually on a hard drive, the outside is fast because it's, think of it this way. This thing it's always turning X degrees, right? This is turning 120 times a second. But the outside turns a lot more than the inside, right? So the outside, the magnets are the same size. It's not like they're bigger. This isn't, I guess something like a, what's a stupid format called? Yeah, it's not something like RCA CED where, they were running at CAV, but, they had to, I was always 180 degrees for one field. This is not that stupid. It's not like CAV laser disc or anything either. This is, the magnets are being the same small size, and instead it usually reads faster. However, this drive is excellent because I've noticed that on the outside, sequential speeds are over 200 megabytes per second. But that's not something, that's nothing compared to the 500 that the SSD does. But it's impressive. 200 megabytes per second on the outside. The speed on the inside of the platters, where they're turning a lot less, so you'd expect them to be slower. is still over 180 megabytes per second, which is very, very impressive. Usually hard drives are really fast on the outside, hence why they start on the outside, and they tend to slow down as you get to the center of the drive. But in this case, the performance is excellent, and it stays pretty much constant throughout the entire drive. Now, of course, if you try to do 4K small reads and write, the head's going to go crazy, and your performance will drop significantly, which is very unfortunate. But of course, that's the way mechanical things work. Hey, I guess think of it this way: it's a lot faster than one of these things. Haha. This is from a prop that I basically, well, I don't have a tape drive, but it's from a video I made on tape writing schemes. Yeah, so very good sequential speed. So we'll definitely be using this, especially because I work with a lot of audio video stuff. And for NAS applications, realistically, remember this. Those two Ethernet ports on this motherboard are gigabit. There's a reason why I use separate NICs, and that's for that reason. Because gigabit is, well, you can get 2.5 gigabit NICs, or you can get SFP NICs for real cheap. Actually, you can get SFP NICs for really cheap. It's the cables that are expensive and the transceivers. But you can just use direct attached copper cables, which are also expensive, but a lot cheaper, just to connect your NAS to your computer, and you can get 10 gigabits per second. Very nice. But anyway, a gigabit per second is equal to 112 megabytes a second. 120 megabytes per second. So if this drive can do 200, we're going to be bottlenecked not by this drive, but by the network card that's limited to gigabit. So who cares if the drive can do 3 gigabits per second in that case? So that's something to note. Now, beside this drive, I wanted a second larger capacity drive. So I went ahead and I had bought this Western Digital Red Plus. This is actually a NAS drive, and unlike that Seagate one, this one was not shucked. This is a legit retail 14 terabyte WD Red Plus. And you know what the worst part is about it? It's broken. So I cannot use it. So that's very unfortunate. I wanted to have the 10 plus 14 terabytes. This one for that one for my personal files, backups, projects I like to work on. This one to have archives, data hoarding. I guess anything old like that I wanted to archive, because this is 5400 RPM performance. It's technically 7200 RPM drive. This is also a helium drive. You can tell because if I turn it around, you will see that it is fully sealed, unlike it does not have the air holes that a normal drive would. WD does make their 8 terabyte drives. I do like the Seagate drive more, actually. You know, this is nicer, full metal. Also, this one works. This one doesn't. So, WD, in their, if anyone is curious how this broke, I believe it is part of their shipping problem. That they shipped the hard drive in a cardboard box with only a teeny bit of bubble wrap. And so I think it got destroyed during shipping. And anyway, I'll have to RMA that. So until then, no 14 terabyte drive, very unfortunately. As I said, I wanted to use that. But I guess today's not the day. So we will not be sticking this into this computer. It'll wait for the RMA. Now, a lot of people like to use 4 of the same drive type, for example, for their RAID arrays. And I wanted to have 4 drives in here, but it's just cost prohibitive, right? I like to remember, my whole theme with this build is performance per dollar. And if buying one 10 terabyte drive is cheaper than buying multiple of the smaller kinds, then I'd rather buy this. And then because I like to think of it this way. Prices on these are coming down, right? And density is going to be more important. So I buy the best price per gigabyte, which these days is between 6 to 10 terabytes, at least in Canada. You can get Seagate 6 terabyte externals for 120, 8 terabytes I've got it for 141s, so on. 10 terabytes for 200. Basically, $20 a terabyte is what you want to look for. If you cannot find a hard drive for $20 a terabyte right now, don't buy one. At least not in Canadian dollars. Because I can guarantee you that there are multiple sales per year where they will easily drop to. There's been 5 terabytes for 100 last year Black Friday. I don't think that ever got repeated. I should have bought one then, darn it. But 6 terabytes for 120 is quite common. 10 terabytes for 200 has also happened. As I said, this is shucked, and in fact, when a number of people have shucked these, they've gotten Iron Wolf Pro drives, which is great if they want to use it in NAS. Iron Wolves are great drives. There have been people that have gotten Exos. I have bought 2 of these, completely different times of the years. Both times I've gotten Barracuda Pros, which I guess are technically worse drives, but they're perfectly fine in my use case because these are meant for desktop to workstation use. Iron Wolves would be NAS use. Their main real advantage is if you have 4 drives. I don't, so it's fine. Now, the reason I got a second WD drive is because I get a little paranoid. I don't like using hard drives of the same batch, because if you know about the bathtub failure curves, basically what that's going to mean is if one drive fails, the other one is really close to failing. And that could mean that before you get a chance to recover your data, you lose the second drive. Whereas if I use 2 completely different drives, now the statistical probability that both of these will fail simultaneously is a lot lower. If this drive dies, I can probably recover it from the other drive, like while I have an array rebuilding or something. So I wanted to, it was part of my intention to use either WD or Seagate drives, or use 2 different types of hard drives at least to stagger them. Just like how I don't make all my backups on the same DVDs. I have about 4 different DVD brands. I got the Taya Udins, I got the CMC, the Redata, so on and so forth. Just because you don't put all your eggs in one basket, folks. Now, that being said, I'm also the single guy that destroyed all 16 terabytes of my data by a single broken command. So make sure you check what you type on Linux as well, because remember, Linux will do exactly what you tell it to do. And if you tell it to do something that it shouldn't do, it will do it. Very happily, so I've gotten rid of that. Anyway, the final disk that we're going to be putting in the system is this 500 gigabyte WD Blue. So this is from my when I first built this desktop computer in this chassis. I had a 500 gig. This was my boot drive. This is 7200 RPM. It's fine. Actually, the 10 terabyte one is faster. And you might be saying, why the hell would you put a 500 gig hard drive in a computer these days? You know, this isn't worth anything. But remember, I have 100 gig drives that I still use. So, you know, it only recently occurred to me that I can buy a 120 gig micro SD card right now instead of my 100 gig massive 3.5 inch hard drive. And well, I guess maybe one day it's supporting that sector, so I'll probably stop using that drive sometime real soon. But until then, this is my WD Blue 7200 RPM drive. Slower than the other one. This has clocked like 40,000 drive hours on it, but I basically just want to use it as a scratch disk, right? So the way I work is I like to. Sometimes I'll just come up with an idea for something, and for that I'll want to use a couple hundred gigabytes all at once. But I don't want to use it on the SSD because SSDs have limited terabytes written life cycles. I want to do it on something that, you know, doesn't really care what I write to it. So having a scratch disk is great for that because you can kind of just use it for temporary. Basically, the whole thing is like a temporary project file, and then you can do whatever you want with it without worrying about it too much. So if you have old hard drives, you can use them as scratch disks, which works perfectly fine. And that takes care of storage. So the next component I want to talk about is cooling. So in my case, I have chosen 2 Cooler Master Hyper 212 EVOs, and I will tell you right now, do not use this configuration for a couple of reasons. Well, the main one is this is not value. As I said, I wanted to go for performance per dollar. These are overkill. You should not spend. So I spent over $50 per cooler. So I spent over $100 on these 2 coolers combined. I have stress tested the CPUs. The maximum temperatures they have ever reached is 55 degrees Celsius. Not above ambient in total. My room is an ambient temperature of about 21 degrees. These are absolutely overkill. I went with these for a couple of reasons. A, I wanted something that I knew would work with LGA 2011. And this does work with LGA 2011, at least for square ILM mounts. Remember what I said on the motherboard? There's narrow ILM and there's square. The Hyper 212 EVO will work on square ILM mounts. I cannot promise anything. I don't think it works on narrow. You'll want a different cooler. But these are overkill. You should not buy coolers that are $50 each, and I cannot return them, and I can't really sell them used, because like if I sell these used, I'm gonna have to buy a new cooler anyway. So I just thought, well, I guess I'll keep it until I eventually upgraded the system to maybe an Epic or later newer generation Xeon. But this is my current cooling setup. These also have this other downside that normally tower coolers are good, but in this case the motherboard doesn't have very much cooling, so I would have preferred something that's downdraft, just to force some air over the motherboard's MOSFETs and VRM, just to cool that down as well in the process, because in this case the motherboard's really kind of getting, well, it's getting fried, it's getting toasted in between the other components. So that's something to note. The fans for these are, I'm just using the fans that they came with. These are 4-pin fans. They're kind of dusty because I haven't taken very good care. But, you know, we can see the nice effing flicker of the GE bulbs that I'm using. Fascinating. I hate modern LEDs sometimes. LEDs are great in terms of power saving, but some of them flicker so much that they're horrible. Anyway, this one has... they have these little clips attached on them so that they can be clipped onto the heatsink. However, because the spacing on the motherboard is so small, I wasn't able to get the second one mounted properly in the heatsink. So as you can tell, I mounted it backwards. So here's how you can tell. So the one will mount on the intake, the other will mount on the exhaust. The way you can tell is if you look at a computer fan, the side where you can see the spinning is the intake. The side with the sticker, with the hub, is the exhaust. So here's a different fan. This side is the intake because it's the spinny part. This part with the solid part, this is the exhaust, so it will blow to here. You also know because they have little arrows conveniently put on them. So this shows you that the airflow is this way and the fan spins that way. So it's marked on that side. Once again, so it's intake on this here with the spinning part and exhaust on the side with the sticker. Alright, so this one, you can see the spinny bit. So this is the exhaust and the static part is here. So this one's going to clip on backwards. It does work the other way, but I found it really, really hard to put the fan in. So I'm not going to bother. I don't care. I'm just going to run it backwards. All right, that's the cooling. So each of these you'll need the mounting bracket. Now with LGA 2011 Square ILM, you do not have a backplate. So you're going to directly just screw these standoffs. You're going to screw these standoffs directly into the motherboard's mounts. And then we can get going after that. Because of the constraints of how tight the case is going to be after we put the motherboard in, I do recommend mounting a lot of things to the motherboard first. Alright, so that's our cooling. Next up on the agenda, power. So yeah, my advice would be Hyper 212s work, but if you can, get something cheaper. Alright, so let's talk about my power supply. My power supply of choice for this build was an Antec Earthwatts Gold Pro 750. Now, you might say Antec, oh boy, that's a name I haven't heard in a long time in the power supply realm. And you'd be right. This power supply is, well, it's still manufactured, but that's because this isn't an Antec power supply. It's actually just a rebranded Seasonic. Now, there are a couple of considerations you need to make when choosing a power supply for this system. So I chose this one for a couple of reasons, and let's start. So this power supply, first of all, it's 750 watts. My old power supply was 430, which was fine for the single i7 and GPU, and that was pushing it. But now we have dual CPUs. Technically, if each one can pull up to 100, they won't, but if the GPU can pull 200, if it's 400, I want a lot of leeway, so I went with 750. If I were to upgrade the GPU, I might need something more powerful, like an 850 or 1000. But given how expensive power supplies were at the time I bought this, which was last summer, thanks to the stupid crypto mining craze, 750 was about the max I was going to get. So as I said, this is just a rebranded Seasonic power supply, and there's a number of good things about it. It's 80 plus gold. Now, Steve from Gamers Nexus did an excellent video about why the 80 plus certification isn't everything you need to look for, but it definitely is a good starting point, and it has all of the security checks that you would want: short circuit protection, overcurrent protection, and those are all fine. Now, another cool thing is another sign is if the power supply doesn't say continuous power, I would have been suspicious. So 750 means it can do 750 forever, indefinitely, basically. Whereas some power supplies, particularly on like cheap sellers, are known for like 700 watts peak power. But those aren't 750 watts at all. They're only going to provide, say, like 600 or 650. And they can only provide 750 for like these short bursts of time. You do not want that. You want a continuous power for reliability. So this is, you know, as a standard power supply, has an IEC input, 120 to 220 volts. Of course, if you're a North American pleb, you're probably going to be stuck with 120, where you'll get lower efficiency. If you want to be unsafe, you can, of course, bridge together two circuit breakers to get two phases. So instead of neutral, connect one to plus 120, the other to negative 120, and you go 240 volts, and you'll get the efficiency at the expense of being slightly more dangerous. Maybe do it in your kitchen or something. We have the fan. There's technically two versions of this power supply that you need to watch out for as well. Why are there so many things with these scams? Darn it. So there's this version, which is manufactured OEM'd by Seasonic, that has straight with this type of fan grill. There is apparently another type of this power supply out in the wild that has the concentric rings for the fan grill. That one is lower quality. You should watch out for it, but this one should be fine. Now, one of the deciding factors for this, by the way, this is surprisingly compact for 750 as well. I remember power supplies being a lot, deeper. So if you look at this, it's practically square. It's thinner, it's narrower than it is wide. Usually they're a lot wider that way. Just for those wondering the specs, I will read them out. Any spec heads in here? 100 watts on the 3.3 and 5 volts. 744 on the 12 volts, so you should be fine. And this is a single rail design, so this means that you don't need to worry about balancing your CPU and your GPUs and your hard drives on the different rails to make sure they're roughly equal. Single rail, you can load it however you want. Now, one of the reasons I chose this power supply was actually partly for the connectors. It's not fully modular, but that's because I don't give two hoots about cable management. And you see, the thing is, why make a modular power supply when fully modular, when, for example, every single computer needs a 24-pin, right? Because there's no getting away from it. You're going to have a motherboard. Every single computer is going to need an 8-pin for the CPU. Like, I don't, those don't have to be modular. I guess maybe for cable management, so you can cable mod your cables, whatever. I don't give two hoots about that. In fact, I don't know if this is, a lot of people will like the, it's the nice flat black cables. Man, if you're someone like me that just likes cutting into, like, I've spliced into my old power supply cables and just soldered like LEDs or whatever that I want. Having the cables color coded was a godsend. You know that black is ground, orange is 3.3 volts, red is 5 volts, yellow is 12 volts. Green is the power on, purple is negative 12 volts, blue is whatever. Or sorry, purple is like 12 volts 5 volts standby or something. So you knew the red, yellow. I knew what was 5 volts, what was 12 volts. With this, good luck. Now, let's talk about what's built in. So we have the essential 24-pin that I mentioned. We're going to need this for our motherboard. Another interesting part of this power supply is that they have chosen to give us two 8-pins. This was perfect for our case because our motherboard has two CPUs and each CPU needs an 8-pin. So this is excellent because, well, we're going to need to have dual 8-pins anyway, and this has them built in. Some power supplies, for some reason, for example, I've seen 750, 850 watt power supplies that only have one of these, and they just ship with more GPU. I guess they think you're going to do like 4-way SLI. Yes, you can adapt this to this. As I said, if you do not plug these in for each other, their pinouts are different. You can jam them, but their pinouts are different. You will cook something or short circuit. You can adapt it, but why? The adapters are really stupid and clunky. It's just more convenient. I find it interesting that they still let you disconnect them to make 4+4. I have not seen. My first computer used only a 4-pin. Every computer I've built after that has always been 4+4 = 8-pin. Here, can this focus? has been 4 plus 4. So when you just plug it in, you just join these up and you plug them in like that. There's technically a little clip that's supposed to hold these in place, but the clip is pretty terrible. So yeah, this has dual 8 pins, which we need. And finally, that leaves the last remaining connector, this one, which is the dual 6 plus 2 pins, so up to dual 8 pins. Generally, I like to connect, I would run 2, like if my GPU wanted 2 of these, which it doesn't, I would run 2 cables, just so that I'm not overloading this one cable. And realistically, it has the output anyway, so, you know, why not? But this one cable can do it. My GPU in this build is going to need 1 8-pin. My previous GPU needed 1 6-pin, so but we should still be fine. Now the semi-modular part is this. We have 3 SATA or Molex connectors and 1 PCIe connector. In my case, I am going to need the SATA Molex cables, so we can, well, I'll show you how to plug them in into the case, but essentially these cables are kind of stupid and kind of good. They have 3 SATA on each harness. I'm going to move this out of the way. I don't think it's necessary now. Each harness has 3 SATAs and 1 Molex at the end. Great for jamming your cables into, as I said. Do not, you know, there's the old saying, Molex to SATA, lose all your data, or Molex to SATA, lose all your data, whatever. The only quirk with this was that this is, the way these are spliced is so that you would go from the power supply to this top cable, and then these go down. Why would I go to the top one and then go down? To me, it would make a lot more sense to go to the bottom one and then daisy chain up. But then you can't do it. You need to mount your hard drives upside down. So you go to the top one and you daisy chain down, which is kind of bizarre. But anyway, you can connect up to 3 of those leads, and I will be using 2 of them. One for my SSD and an optical drive, and the other for my 2 hard drives. I will not need the extra PCI Express. Alright. Alright, and before I get into the accessories, let's talk about the case. The case, this is a Corsair 200R from my original first computer build I built on this case. It's good in the sense that it is almost entirely toolless. It is bad in the sense that it is almost entirely toolless, and it's not as flexible as some cases. Now, this isn't a full review by any means, but I'll talk first about the modification I had to do and why you might want to pick another case. There used to be a standoff here. As you can see, there's no longer a standoff here. Same with here, here. The motherboard standoff holes don't perfectly line up. Oh, and here. So I've had to rip off this standoff, and I think this standoff. Because, see, for some reason, instead of like the Cooler Master case where there were no standoffs and you just put standoffs where you want them, which is, in my opinion, the good way to have done this, Corsair went ahead and put standoffs everywhere, and then you can add even more standoffs if you want, which is a bit more ridiculous. So I couldn't remove them, so I had to rip them off. If this were a case like the Cooler Master one, you'd be able to unscrew them, and then I would have had to do this. This is stupid. Because now this means that if I attach another standard ATX motherboard onto it, I won't be able to use all of the standoffs anymore, because, you know, they've been removed. So that's that. In terms of the case, there's rear fan. There's also a front fan. These have been replaced by me because the original bearings on the Corsair fans are dead by now. There's also a fan I put on the top. Doesn't really do much. It's just exhausting right now. But I have more fans that I put. I usually tape a fan to the back of this, and I'll talk about that in a second. But yeah, now good things about this case. I guess there's the filter for the power supply fan. I don't have as much positive to say, unfortunately. I mean, it's easy for first-time builders. I've basically just been using this as a shell, right? I have not closed the side panels on this in months. I have both the side panels under my bed. I don't use them. I just like to keep it open. Better airflow. So much dust, but whatever. Now, as you can see, this has the standard 7 PCIe expansion slots. We cannot use the top one because of the motherboard, but I do wish that the space that there's a considerable amount of space here, and I do wish that this section had been allocated for a side-mounted GPU. I think that would have, I mean, in my opinion at least, it would have meant that I would have been able to use a riser, mount the GPU sideways, and get back a PCIe slot, but I can't in this case. Alright, and I guess other general complaints, well, I mean, other than the motherboard tray standoffs, the other thing I don't like about this case is this hard drive cage. So on like the case like the Cooler Master, the hard drives are mounted this way. Like one drive here, I'll demonstrate. They would go like this, such that the drives are in this orientation with some space between them so that there can be some airflow. The drives are mounted instead like this, and they're packed really, really, really close together. So the drives get quite hot, and there's no real way to mount a fan in the front, and even if you did, there wouldn't be very much airflow. So I've had to put a fan either on this side, or more realistically, I've been mounting such fans into the oh, that mic has kind of worked, into the rear of this, just to get some airflow, air flowing over this. So that's quite unfortunate, at least from my view. Alright, so the front panel of this was fully plastic. I have a demonstration of that over there, but also there's no real mesh or anywhere for the air to flow through it, so that's another bizarre complaint that I would have. So here's a look at the front. This is the front intake fan, of course caught on its own cable. Here's the 3 optical drive covers. I've just taped over the LED so that they don't wake me up at night. Headphone, microphone, and 2 USB 3. So it's an alright case. As I said, my main reason for choosing it was that the motherboard fits in it. So alright, and also the fact that I already had it because it was the case I used on my existing computer. So there you go, that's the rationale behind excellent Corsair 200R. Well, not excellent. Alright, here's another one of the fan controllers that uses Molex to set the fan speed. Alright, now let's talk about expansion cards. So here I have the GPU. This is an MSI Armor RX 480. Now, I bought this, thankfully, before the GPU craze started, back in early 2020. So I was able to get this for, I believe, about $150, which is not excellent, not like Linus Tech Up Scrapyard Wars deals, but what I would consider acceptable. And this was a considerable upgrade over my GTX 660. So this is a 4 gig card, that was a 2 gig card. Much newer, also has built-in video encoding so that I can, with the VA API. And the big thing is that this works with the AMD GPU driver, so it doesn't need the glitchy Nouveau or NVIDIA drivers. In fact, the GTX 660 with the Nouveau drivers wouldn't work, it would just freeze. So I had to use the proprietary drivers, whereas with this, the open source drivers work just fine, which is excellent. It's actually something that I cared about and considered when choosing the GPU. Now, this GPU isn't great. As a company, I'm not necessarily the biggest fan of MSI. I don't think their quality is necessarily up there. These fans, for example, they say MSI. This is not an MSI fan. This is my second aftermarket fan for both of these. The first fan started rattling. I think the bearings died on it, so I replaced it with one off eBay. And those ones basically had so much resistance that the fan could hardly spin after a couple months. So I had to buy a third set. This one's from, I believe, AliExpress. And it's working fine now, but there's so many quirks with it. For example, the fan header is here. In the old one, this cable goes around and then goes into here. But in this case, they made the cable so short that I have to run it from here, and it almost interferes. So, you know, a lot of really questionable. I mean, that's a fault of the aftermarket fans, but that's kind of dumb. This is a full PCIe X16 card. As I showed on the motherboard, there's a one open-ended slot, so that's the one we'll be plugging it into. We'll of course only be using X8 speeds, but I think for most applications that should be acceptable, and that should be fine to good performance. So I don't think I'll have any complaints there. Yeah, so I just have complaints about the fan and the fan cables. Power delivery on this card has been okay. There is coil whine if I load it. I can hear it. In fact, it interferes so much with like my sound card, for example, because I think it might be drawing too much power. I don't know. That I can hear it when it's like done between frames when I'm rendering a video or encoding with it, for example, which is really, really shady. But oh well. On this side, you can see it's a single 8-pin power connector. So that's how we will connect it to our power supply. Anyway, yeah, the RX 480, mostly I like it, the good drivers. I don't like this physical implementation design of the card. Alright, and video outputs, we have DVI-D. There is no analog output at all, so no VGA and no DVI-I. You will have to use active adapters, digital only. 2 HDMI, I have confirmed that these are both HDMI 2.0, they work at 4K 60 with my monitor. I know people are crazy about 2.1 now, but I'm just happy that it's not HDMI 1.4. And then we have 2 DisplayPort connections. So these are DisplayPort 1.2, I don't know. They support 4K 60. I like DisplayPort more than I like HDMI, so I've pretty much always used the DisplayPort connections. It's more flexible, works nicer. But yeah, this will be our GPU. Bring out the next accessory. So the two things that we're missing on this motherboard that really jump out to you, there's no video outputs, and the second thing is audio. This is my solution. This is a PCI based sound card. This is based on the SB0410. Also, the driver is the CA0106. So it's the SB0410 with the CA0106 driver. This is a Creative sound card. So this is an old Creative Sound Blaster. This is a Sound Blaster Live. So it's not the top of the end series. Creative had a number of different, I guess if you want to call them series of sound cards. So the Live is not the top tier one. It's one of the lower end cards actually. The higher end ones were, I forget exactly what they were called, but what mattered to me is that on my old computer, on the one with the Asus Z87, I could hear hissing through the headphones when the computer was passive, and in fact on this card I can hear it through the headphone output as well. So I don't like using this headphone output because this headphone output I found is very prone to interference. So if I'm using the GPU or I'm loading the CPU, I can hear it through this, which is very annoying. And it's also, there's hissing because it's goes through a separate amplifier. So instead what I've been doing is I use the second output. This is the rear channel. So by the way, for the uninitiated, I should show the outputs first of all. So we got the blue, green, black, yellow. The way this works is these are your outputs, the blue is your input. So the blue can be dynamically switched between mic in and line in. So they use the I2S internal connections, because when you open this up in Also Mixer, you'll see a number of connections. You'll see AC97 in, I2S in, direct aux in, so on and so forth. This can be mapped to mic in or line in using the I2S inputs. And one will determine if it's stereo or mono, and if you choose mic, it'll give phantom power of 3 volts or so. And that's just the power. Things like lav mics or headset mics, those condenser mics, they usually require about 3 volts, so you can send the phantom power down. Line level obviously doesn't do that. Mic also goes to an amplification stage, whereas line level audio doesn't need that amplification. Green is supposed to be your front speaker out, or your headphone. Black is your rear speaker out. This is your center / subwoofer, so it's made for 5.1. 7.1 would also have the gray connector, I want to say. There's another one. That's used for the side speakers. That does not exist in this case because this is 5.1. So yeah, I like using this connection for my headphones, is for the speaker. And if you've seen my last video on Linux audio, you'll know that I'm a big nerd about that stuff. So I like using Pipewire, because Pipewire has a pro audio mode. So alright, so for the sound card, the way I've historically done this is, I might have talked about this in my Linux audio video, but I used to use Pulse Audio to create a virtual sync. So I used 5.1, I used the 4.0 channel output, so it would use both of these jacks, and I made two virtual syncs. One for headphones, one for speakers, and then Pulse Audio would map that phone to this one, and to this one, speaker to this one. Now with Pipewire, it's even easier, because Pipewire has a pro audio mode, and what that does, instead of, it's actually really cool. Instead of using this as 5.1 channels, for example, in a surround sound system, it will let you separate the output. So I can use 3 stereo outputs, and I would be able to use more stereo inputs. So I think that's actually very cool, and I would argue considerably more useful, particularly for someone like me. Now, of course, some would complain that the rear speaker output doesn't have the same amplification as the headphone amp, so it doesn't go as loud. But I use Sony's MDR7506 headphones, which already have a very low impedance, so they don't really need any amplification. So it sounds perfectly fine just using the speaker output. I don't need the headphone amp, and in fact I think that amp just adds noise. Now you might notice that this has the outputs on the back of the card, and not as many. A lot of modern sound cards are prepped for 7.1 surround. There's no toslink, no optical. It's very bare bones. But what we can do is they do have this little adapter, and what this does is at least it converts it into HD audio. So in this way you can use the headphone and microphone ports that are on the front of your case, and they will work as you would expect them to. They work just as regular headphone and microphone ports, so you don't need to worry about dealing with at least that aspect of things. Now as I've shown, this is a PCI card. There are a couple strategic reasons why I chose a PCI card. The main one is this motherboard. Given that I'm going to want to add M.2, add an HBA, add USB 3, I'm going to be short on PCI Express lanes. So it makes sense that we have this PCI port laying around, doing nothing essentially. We should take advantage of it. And you can't load something high bandwidth onto it, but something like a sound card isn't really high bandwidth, so it should work for this application. And as I said, I wanted to use an analog NTSC capture input. However, that card is 5 volts only. A key part of this card is if you look closely at the pins, you'll notice that it has the data portion that I mentioned earlier, but this is a universal card. What that means is on a 5-volt motherboard, you plug in here to here, just like this with the notch on this side, and it'll work fine. So that was, for example, like my old desktop. And you'll know that because the notch is inverted from PCI Express. On a different motherboard like this one, you use here to here for 3.3 volts. This is the 3.3 volt pins, and you have your data. So this is universal because it can work on both 3.3 volt and 5 volt motherboard systems. So this will work perfectly fine for our application, which is perfect. That's exactly what we want. We wanted a sound card, something that can use that free PCI lane. Something that can use that free PCI lane, and this can do it. Alright, so as you can see, the main audio processor is a Creative CA0106, as I said earlier. The sound card is the Creative Sound Blaster Live. This is essentially that chip. There's a number of other, probably some digital to analog conversion, probably some amplification steps, filtering, so on. There's probably a number of other components. Now, remember, this is from an era when I mentioned this in my Linux audio video, but this card has features that you wouldn't find in a modern sound card. For example, this supports hardware mixing. What's hardware mixing? Well, remember, at the time, computers weren't necessarily fast enough to do digital signal processing. So if I had two programs that wanted to play audio at once, the goal of a hardware mixer is that both of those programs can send their audio to the sound card, and the sound card will combine both of them and mix it into the output. So it's hardware mixing because it can take in multiple inputs from software and mix it on this hardware chip so that it can send one output. And in fact, this still works on Linux. If I mount this card with ALSA, I can launch 3 programs that use ALSA at the same time, and this card can hardware mix them down to a single stream, which of course you never see on like the new Realtek whatever Realtek chips, because those are single input. So if you look at the Realtek chips, what you will see is if one program's playing, no other program will be able to play to the card, whereas with these you can't. Think of it this way: imagine I could use my webcam in 2 different applications. Like, this would do it. There's other cool things. For example, there's hardware memory, so you can load sound font files, like SF2 files that's used by MIDI. Because remember, computers presumably weren't fast enough to do the MIDI synthesis in real time. So this card, you can load your MIDI instrument files onto this card, and then this card can generate the MIDI instruments. So it's again another neat feature that, I mean, who would use this today? Right now you can just launch up a synthesizer application and it creates all your MIDI for you. So there's a lot of hardware in this that probably goes what I will call, underappreciated. Really clever for its time, but I guess it's like a relic of the past given modern computers. It's unnecessary. It's still very, very interesting to me to learn about, though, just to find out how this used to be done before the software age, I guess. Because there are a lot of really clever hacks. All right. So this is my choice of sound card so that we will be able to hear audio and record audio to and from our computer from within Linux, so that, at least now our server motherboard not only has video, now our server motherboard will not only have video, but we will also have full duplex audio, and you'll be able to hook up speakers, headphones, so on and so forth. So this is my choice of sound card. There's of course other alternatives. A lot of the modern ones are of course PCI Express based. There's a lot of generic no-name ones that I would try my absolute best to avoid, simply because a lot of those are, I mean, I don't want to call them absolute garbage, but they're pretty garbage, because they almost certainly never have proper filtering. They're just, yeah, in no way would I recommend them. They always end up with noisy output, and they're never going to have the full feature set. So go with a used. These are very cheap on eBay. In fact, you don't need to go for a live. You can go for something a lot higher end. Something, I mean, you can also go. ASUS has a number of high-end sound cards. You have your Sonars. You have Creative Audix. And I'll list some popular ones down below, but you can just pick and choose any cheap one to do the job. The next card on my agenda is a USB 3 adapter. Now, as I said, by default, this motherboard does not have USB 3. So the final real lacking I/O is USB 3. And not just on the rear, but also the front panel, because as you saw on the motherboard, there's a couple USB 2 headers, but I mean, most devices these days have USB 3 connection, and I'm not getting into USB-C. You can get the same cards that have USB-C on them. I don't particularly have any USB Type-C devices, so since I don't have any USB Type-C devices in particular, I'm not so keen on that last point, so I focused on a card with USB 3. My number one objective was to find a card with a chip that had good support with Linux. Ideally, I wanted a card with multiple hubs, with multiple USB routes, but of course that's not going to happen unless I pay too much money. So this card was surprisingly expensive. This one was, I think, about $40. Now you might wonder, why would you pay that much, given that there's cards for $10? I struggled to find dude, it seems such a simple concept. PCI Express to USB, very common, right? This should be really, really, really common. Except almost every single one would have tons of these negative reviews that were like, it either fried the devices connected over USB, or it fried back over the PCI bus and got rid of some CPUs. So this has been going strong for over a year. Hasn't fried anything yet. And it has a Fresco Logic chip. A lot of these are going to have chips by either Fresco Logic or by Amlogic. Amlogic is the other, I guess, popular chip maker for these types. Some of them will have, probably Realtek has a chip. Realtek makes ASIC chips for everything. So there's almost certainly going to be equivalent devices made by the likes of folks like Amlogic and Realtek. In my case, it doesn't matter particularly too much. So I'm just using this in a tech card. This has 2 USB 3.0 ports on this side here. And this side has a header. So I can connect the USB 3 from the chassis over, so I can get 4 USB 3 ports. They all share the same root, but I think that's expected. So there is the chip that's at the center of this. That's the Fresco Logic PCI to USB 3 converter. Of course, as I said, there's ones with USB 3. There's one thing I don't like about this. They don't have an auxiliary power connector. So realistically, it should be fine because the PCIe bus is rated to give up to 75 watts to the card. But given that the motherboard is already strained, I would have liked if they do make versions of these with SATA or Molex connectors, and I wish I had found one that had one just to give me that peace of mind. Because then it would have been able to get data as I expect from PCIe, but it would have been able to at least get the power from the power supply instead of relying on the motherboard. Because I do like connecting higher load devices to this, right? For example, like a camera or the microphone amps or video capture cards, and I'm always worried, is this going to provide enough power? For example, my keyboard backlights, right? That's how I blew the fuse on the motherboard, was I turned on the backlight. So I'm never sure if it's going to be able to handle it. So anyway, this is the USB 3 card. Pretty basic, driverless, worked in Linux fine. I'm skipping my other card, which was a PCI Express to Firewire card. I think I talked about this earlier in the video, but I used to have a Firewire card because I wanted to be able to connect a mini DV camera directly to capture digital files right off of it. And historically, I've also worked with an audio interface that used Firewire. But it's X1. There's 2 cards that I'm not including. One is the Firewire card. The other is my Wi-Fi card. Both of those are PCI X1. They could have gone to the bottom slot, but instead I'm using that slot for USB 3. This is my next card. This is the one I'm using in PCI Gen 2 in the X4 slot. This is an LSI 9212 4i4e. This is a SAS HBA. So an it's commonly also called a RAID card, but a RAID card would mean that does hardware RAID on these. And I don't like using hardware RAID. It doesn't have a battery backup or anything. So I use software RAID. And for that, HBAs are great. HBAs are basically SAS to PCIe adapters. Basically what they will do is they can take your, they can convert to and from the hard drives over into PCI Express for something like Linux to talk to. I chose this card because it's very cheap. This is, you can have this for about 40 Canadian dollars shipped. These are all refurbished, used cards, whatever. It has 4 SAS connectors, which are, as I said, are the same thing as SATA cables. So if you have, I had bought SAS hard drives, which are usually cheaper if you're buying them like refurbished. You can just use a regular SATA cable, connect from this card over to your hard drive, and it should work without any problems. SAS is also backwards compatible with SATA, so I can take my SATA drives, plug them into this, and they show up no problem. So this on this PCIe, this card is a PCI Express 2.0 X8 card. So I guess I'm losing about half the bandwidth by running it in PCIe 2.0 X4. But I'd rather do that than give up a PCI Gen 3 PCI Express Gen 3 slot, the only one I have left, because remember the GP takes up both. So I have only one Gen 3 slot left, and I'm not going to use it on this because this is a Gen 2 card. Now if I turn this over here, you can see the 4 SAS connectors. 1, 2, 3, 4, as I said, physically the same as SATA. If I focus here, 6, 7, 8. There's, well, I guess this header over here is for chassis LEDs. So there you go, you have the diagrams for which way 2 LEDs could potentially be mounted in here. This component looks really, really sus. I don't know if you guys can see that. So I want to touch on another benefit to having just a SAS card like this. By the way, SAS is double the bandwidth of SATA, so SAS 3 can do 12 gigabits per second instead of 6, and SAS 2 will do 60 gigabits per second instead of 3. But an advantage is, as I said, each of these are backwards compatible with SATA 3. So if you notice, I said that on the motherboard we have only 2 SATA 3 ports, but we had 4 SATA 2 ports. And I said, well, if you wanted lots of high-speed SSDs or something, well, SATA 2 is not the way to go. You know, it's maybe fine for hard drives, but realistically SATA 3 would be better. Well, here we go. This card adds 4 SATA 3 ports to this to the computer. So all of those can be used with hard drives or SSDs in whichever configuration makes sense. So that's always a good sign, I would say. I'm also going to give a shout out to this is the SFF8088 connector. So this is for the 4E. So as I said, 4I for E means for internal and for external lanes. So this can also run 4 SATA or SAS devices over a cable. I have one of those cables over here, but it's commonly used in external hard drive enclosures. If you have like a 4 hard drive cage or something, a lot of those can use this. Oh right, and something I didn't mention at all SAS and SATA drives are hot swappable. So this card is SAS perfectly supports hot swap as long as your drive does, and this does. For drives, it kind of depends on the backplane, right? Because they need to have specially designed power connectors so that the ground connects before the power does. You'll know because it'll be extended. But assuming that your drive cage does, which most of them do, you can hot swap, plug the drives in and out of this. And on the motherboard, all 10 of those SATA ports, the 4 on the main chipset, the 4 on the other chipset, all of them also support enabling hot swap functionality. So that's very good to see. So you'll be able to easily swap hard drives in and out and do whatever else you might need to do with them. So overall, I would rate this a useful addition to your system. You can use it to get extra SATA 3 ports, get some SAS, gives you some flexibility when you're purchasing drives. You'll have the option to purchase enterprise drives that are SAS based, get a drive cage in the future, so on and so forth. This case doesn't even only supports 4 drives, so it's not particularly useful now, but if you wanted to upgrade this to something like the Cooler Master, or case with mini 3.5-inch drive slots, this could be a very useful upgrade. Finally, the last one I will show is this. This is the M.2. So this is just, I guess, the last step to modernizing this system. And this is what I'll be using the PCI Gen 3 on. So this is a 2 SSD device. These are rarer. There's a lot of the ones that have 4, 2 on each side of the card. But unfortunately, this motherboard doesn't have any other X16 slots that we can use for that. So we'll have to use these X8 ones. There's another variation of this. To start with the most basic one. This is the most basic card you can have. It just takes 4 lanes and makes it into 4 lanes here. There's really not much. There's just a bit of power conversion and a LED. That's about it. These are pretty bare bones, but basically you just take your SSD, plop it in. This is not the right screw for it. This is just something I had done to put the 2242 SSD in. But they work, and they're surprisingly good. These are really cheap, and they can modernize the system. Again, I basically use M.2 as a scratch disk and as a swap file, because I already have the SATA drive to use as a boot drive, so I don't have the need to boot off of this. And the reason I only upgraded to the bigger one was because I wanted to run 2 SSDs with an X8 bifurcation. And once again, your motherboard needs to support bifurcation, which means splitting the 8 up into 4/4. This motherboard does, but I could not get this adapter working for whatever reason. If I set it up to 8, So 0 to 7 goes from here to here. It would find this SSD and skip this one, which is expected. But if I bifurcated 4, 4, it should find this and this, because each one should be getting 4 lanes. But instead what would happen is it would skip this on lane 0 to 3 and find this on 4 to 7. So I do not understand what was happening. I'll just show you how to use this real quick. So it's pretty simple. The SSD is screwed in from the back. If I get the right bit. You can simply unscrew this here. Screw has a little slide-in component like that. Takes out, for example, this is a SK Hynix 2242. Came from my laptop, really Lenovo, shipping 2-lane SoC SSDs. Could have been higher quality, and instead say we're going to put this in. So let me just screw this back in so we don't lose this little adapter piece. I see as I clumsily drop the screw. Alright, so the way this is going to work is you just take your SSD, slot it in, put this piece over here, bring that there, screw, and just screw it in, just like that. And there you go. Now you can add a second SSD in the future if you manage to get this working with this motherboard, in which case please email me, leave it in the comments. I'd love to know what you did. I emailed Supermicro. They of course said that the motherboard's out of their service period, so didn't help there. But yeah, I think I've gone over all of the components now. So let's get building. Alright, and that was part 2. Part 3 is available. Link down below. See you in part 3.